Yes. We lost Mr. Moses' presentation due to network issue. So I'll be calling on the next presenter now while we wait for him. Dr. Jackson Ante, please, if you are online, share your screen and unmute yourself. Yes, it's online. Dr. Jackson, please unmute yourself.
Okay. Good morning, ma. Can you hear me, ma?
Yes, we can hear you. Please share your screen.
Okay.
And please put it on presentation mode.
Sorry,
Dr.
good morning,
Jackson,
ma'am.
please.
1 minute, 1 minute, sir.
Hello, good morning, ma'am.
Good morning, sir. I'm with you. 1 minute. I'm getting my stuff on.
Please hold on. Please share the screen.
Please, sir. Just give me 30 seconds. 30 seconds. I'm on it.
Hello, sir.
Hello, good morning, ma'am.
Yes, sir. Moses
Good
Ija
morning,
is ready,
sir.
sir.
Can you hear me, sir?
The network is back. I'm ready, sir, please.
Okay, go ahead and share your screen, please.
Good morning, ma'am. Good morning, doc.
Just
doc.
let's be patient. Brother. We are going to take everyone. So let's be patient. The issues that we intend to follow the order. The challenge is we have called names and people are not here. Please, it's the same link we are using. Okay, so let's just try to be private. Please don't use phone for presentation because when you share your phone, we are not saying it. Please, we cannot see all these things.
Hello, doc. Can you hear me, sir?
Yes. Yes.
I had intended to use a phone, but I noticed that there will be difficulty in seeing it properly. So I had to switch on my system to use. So please, just give me 1 minute because I'm.
No problem. You keep on doing that.
Hello, sir.
Yeah.
Hello, sir.
So
the network is back. Moses, the network is back, sir. Please. If it's not ready, I'm ready. Let me continue, sir.
Hello.
Are you the one sharing screen or something? The person sharing screen. You are using phone.
I'm the one sharing screen. I'm ready to present.
But we cannot see your screen because you are using phone.
Okay, you cannot see my screen?
Yes, put it on landscape. Put it on landscape.
Okay,
on landscape. Landscape. Okay.
What about?
You can enlarge it better. Enlarge it better. Good. Good. Okay, it's too much. Okay, yeah, it's good now. So can we have you now present? Thank you.
Okay,
You
so
have
I'm
10
Alhassan
minutes.
Tijani. I'm
Okay,
Alhassan
thank
Tijani
you.
by name, presenting on behalf of my team, and I'm the corresponding author. I'm presenting on investigating the effect of temperature on viscosity of some selected engine oil in Lokoja Metropolis, Kogi State. So I can continue, right? Hello, sir?
Yes, please continue.
Okay. Viscosity and temperature. So viscosity is one of the most important physical properties of fluid system. It's a function of shear rate, temperature, pressure, moisture, concentration, and flow rate. Many researchers have studied and reported the relationship between viscosity and physical property of vegetation oil. So what tells me that I go into this research is the behavior of temperature, how temperature affect the viscosity, which is the fluid. So then I determine the physical property of such viscosity, the density, flow rate of different engine oil, such as groundnut oil, Sims oil, olive oil, sunflower oil, coconut oil. However, the depth, the information of the effect of temperature, of viscosity, or fluid. According to Better Oil 2017, define viscosity as a term used to describe the resistance flow at a particular temperature. It is a common perceived as flow behavior or resistance of flow. Viscosity describes the fluid internal resistance to flow, and many thought as measured as what? As fluid friction. So the issue there is that I picked Lokoja as one of my study area because we discover one thing. If viscosity is resistivity that describes the resistance of flow of particular temperature, why that temperature affects this resistivity, affects the engine oil. So temperature itself can be defined as the degree of hotness or coolness of a body in an environment. Lokoja is one part of the country that experience hotness. The theory to determine the viscosity of liquid and its solution still very poor. Some theoretical approach include those that develop what molecular dynamics that can produce. So I selected this engine oil, 3 of this engine oil. The use of this oil such as Amasco, Tonimas, and Climax that used by these Okada riders within the metropolis. So these engine oil are pertinent to lubricant various parts of the motor engine to reduce what friction and minimize unnecessary loss of power. Minimize unnecessary loss of power. The aim is to determine the effect of the temperature on the viscosity. Values on selected engine oil, which are Amasco, Tonimas, and Climax. And the objective of the studies, one is to collect the sample of the engine oil, which are Amasco, Climax, and Tonimas. Sorry, call is coming inside. So Tonimas oil, one is to determine the effect of temperature on the Amasco, to determine the effect of temperature on the Tonimas, and to determine the effect of temperature on the Climax, which are used for this as lubrication. And what? To correlate the effect of the temperature on each of these selected engine oil, and to determine the viscosity value of this some selected fluid. Amasco tonemers at various temperatures, raising using digital viscosity. Here are what the image of the the instrument used to measure the viscosity and the temperature. The thermometer is used to measure the temperature, while the digital viscometer is used to measure the viscosity of the engine oil. Here are the images after collecting the oil. Here are the images. I hope you can see it from there. Hello? Hello? Hello, sir?
Yeah, you can take images, then
Okay.
go to the next slide.
Okay. Here are the images. The next phrase is the methodology. The materials, the viscosity, the digital viscometer and the thermometer are part of the materials that are used. Then the beaker is also used. The Amasco, tonemers, and climbers with laboratory thermometer are part of those that are used, as well as the material used for investigating the temperature. Here are the methodology. The 3 engine oils that were selected from this engine oil were separated into into sample A, sample B, and sample C. The 3 sample were A, which is Amasco, and B, which is tonemers, and C is climber. The temperature range will be from 25 degree, which the thermometer was set at this degree, 25 degrees Celsius, and it will increase. It step from what? From 5 degrees Celsius, which varies the temperature 25, 30 down to 55. Then the first sample, which is the Amasco, was turned into a beaker of what? Of 1 to 4 centimeter. It was heat up to the initial varying temperature using the flame or heating material and measure the temperature using the thermometer. Lower the digital viscometer into the engine oil and the beaker until the surface is level, which groove mark on the viscometer spindle. With then the switch on the motor allow the die to rotate until the steady obtained. Recall still replicate and repeat the procedure for other varying temperature. And for sample B, the same method was used for sample B and sample C. The experiment is carried out in August in Lokoja 2024. The digital viscometer measures the fluid using a rotating spindle or shaft that is inserted into the fluid. The principal viscometer on the principal rotation, which measures the resistance to rotation or spindle of the shaft, is fluid. Here are the components of digital viscometer. We have spindle or a shaft, a cylinder or a spherical spindle inserted into the fluid. A motor rotates the spindle, which control the speed. Tongue sensors measure the resistance to rotation, which is proportional to the fluid. We have electronic control. The electronic control unit process the tongue data and calculate the viscosity. All the values that were collected were imputed into relevant statistics and was measured. So at the end of the day, here are the results.
Hello, Mr. Tijani, you have 2 minutes more.
Okay, here is the result. We have a sample A, which shows the Amasco, sample B show the tonemers, and sample C show the climbers. So from here, you can see the result. The temperature which ranges from 25 to 55 degrees. The viscometer of the first 25, which is 325.8, and for viscosity, for tonemers engine, we have 268.8, and for climbers oil we have 302. 2.9. And the lowest one we have among these, which is 268. So from the result, it shows that the one with the higher viscosity shows that it has the higher resistivity and it will be good for any of the motorists that can use. Here we have the highest one, we have sample A, which is the Amasco, which produces the highest viscosity, which is the resistivity towards the temperature. We have 260, 225 to 2, followed by 302, which is the climax. So the Amasco shows from the result. The relevant statistics were used to calculate this. So from the result, it shows that the Amasco, which is sample A that was placed in some
Mr. Tijani, Mr.
Yes, sir.
Tijani,
Yes, sir.
please start rounding up. Time is up, sir.
Okay. So the result of the temperature for this viscosity used for sample A, respectively, in time interval selected major, the results show that there is no common pattern throughout the temperature fluid increase. The viscosity decrease as the average time fall decrease. The viscosity SA2OD engine oil exhibits significant variation. The maximum viscosity record for this sample A, which is 325, 265 down to 302 respectively, convey. In conclusion, sir, in this study, we have competition analysis that demonstrate the temperature of 55 degrees, which is the Amasco engine oil, has the highest viscosity of 265, while the sample B engine oil has the lowest viscosity of 195. This simply engine oil with high viscosity and higher temperature have a good performance for automobile engine. This prevents wear and tear of engine through the reduction of friction and improve the durability of the engine oil as the engine increase with temperature. Based on this finding, it was revealed that the engine oil sample A Amasco is the most suitable choice for automobile users, both for industry, domestic application, due to their very favorable performance characteristics of the test range. Thank you.
His presentation, please, are there any questions from the online participants first? Please, if you have any question for Mr. Tijani, please unmute yourself and ask. Okay, so while we wait for the virtual participants, do we have any questions from the physical participants?
Thank you for the presentation. I joined towards the end of the presentation, but what I would like to understand is the design for this study. How the units, I'm not sure if I used vehicles this time around, how they were selected, and then generally the design of the study. Okay.
Did you get the question, sir?
The study
No,
design,
sir.
yeah.
Yes, Wabuti, did you get the question?
No, sir. Please let him come again.
First, just asked about the study design. That's how did you, we should speak about your study design.
Yes, I spoke about my study design, which is
Yeah,
Lokoja
and you should
Metropolis.
speak about, yeah. It's not about study location, study design, not location. Study design.
Okay, study design.
Yes.
Hello?
Yes, the study design of the research.
Is survey study design.
Sorry, we didn't hear you.
Survey. I use survey study design.
that's the point. It would be interesting to know how you use vehicles, right?
No, I did not use vehicle.
What did you use?
I
What did
use
you use?
normal. I use normal heat.
Huh?
Heating point. I use normal heating point.
I'm not sure I understand that. Which
You said you use survey of what? Is it vehicles that you survey motorbikes or something? Or those that are selling the oil itself?
what's your unit of measurement? Let me put it this way. What's your unit of measurement?
Okay, my unit of measuring
Yes.
for the viscosity or for the temperature.
Well, what did you observe?
I observe that from my conclusion, that's what I say there.
What unit did you observe?
What I observed.
Is it vehicle or motorbike or humans?
The climate is used by both. Yes, I'm coming. What I observed from the result and from the analysis is that
not from the result. What constitutes your unit of measurement? What are you recording your measurement? From what unit are you recording, or did you record your measurement? Okay, for instance, the temperature you observe from what?
Okay, from 25 degrees.
No. Is it from a vehicle or from a motorbike?
I use heating point. I did not use motor. I heat the engine oil. I heat it.
What did you sample then? You said you
By
sampled.
By applying by applying heat, lighting it up with inside beaker. I apply heat on it. Then I insert the temperature in it. When the temperature.
Maybe should be patient to get it correctly, right? Yes, your sample. Where did you get it? Yes, your sample now. Where did you get it? What did you observe? What's your sample all about? What did you sample from?
Okay, my sample from lab. I took it to lab.
Not where you took it to. Where did you get your sample from?
I bought it from those that are selling it, the vendors that are selling it by the roadside.
That are selling oil, right?
Yes. I got the sample from the vendors that are selling it by the roadside.
Okay, so oil of what? Is it of motorbike, of vehicles, or palm oil?
No, of motorbike. Engine oil.
Okay,
yes.
So those are the question about observation and all of that. I think these are statistical terms, and then a professor of statistics was talking to you, so he was using those language, or maybe you are not so familiar with statistics. You are just doing, but I think these are the things that we need to actually be familiar with when we are delving into an area.
Yes, that's why I wrote the engine oil there specifically. It's not red oil. You can see from the topic, I wrote engine oil.
So what we are saying is that, you see, when you are being engaged in discussion or representation, it's not just, okay, somebody you had presented, somebody didn't see, and they came in later, was asking questions. So he's expecting that you give him answer, not that you wrote NG for him or something. So, but it's okay, it was a beautiful presentation. Any other question? Okay, so I think we'll take the last question for on that before we go to the next presenter. Thank you.
Thank you. Okay.
Yeah, thank you, Tijani, for that presentation. It's a wonderful one.
I know that there are, let's say it's common knowledge that we have different engine oils made by different companies. Climax, and the other two you have used in research are just a few out of the many we have in the market. And then we have engine oils by companies like Total, Mobil, and the rest of them, which have proven common knowledge. Users have attested to it that those Mobil, Total, and the rest of them are better than these Amasco, Climax, and the other one you use. So what prompted the choice of the Amasco, the Climax, and which other one that you used in your research? Thank you.
Yeah, these are the ones that they are majorly using in Lokoja. Most of the motorbike, these are the ones they are using, not that Total. Because that's why I told you that I use survey. Because when I ask them which one are you using, they say Tonima. Why are you using it? They say, no, this one is more better than this one. So there's only few people out of those that I started my survey, those few people that asked, out of 10, 20, you might see it's only one person that is using Total. And why are you using Total? Why are you not using Total? Because people, they say that one is very cost. It's highly cost. So I took my research based on these three, one that have the major, this thing that people are responding to it. This is why they are using it. So that's what prompts me to pick these three: Tonima, Amasco, and Climax.
Very much, sir, for your presentation. Please, can you stop sharing your slides when we have the next presenter?
Thank you. I can go now.
Please stop sharing your slide. Okay. Mr. Moses, you have 10 minutes for your presentation, and please put it on presentation mode.
I'm presenting the topic risk management practices of building infrastructure projects in Niger State, Nigeria, by Giacomo Isetreba Abadora Tidladidi, Department of Project Management. Okay. Mode. Can you hear me now?
Presentation mode. Presentation mode. Can hear you.
Okay. Okay. Now, the abstract. Building infrastructural projects plays a vital role in Niger State socio-economic and urban development. However, they are persistently challenged by cost overruns, time, delays, poor quality, and inadequate risk control. Despite the global acceptance of structural frameworks such as ISO 30,000, their adoption within Niger State construction industry remains minimal. Project execution is largely informal and reactive, with limited integration of systematic risk management principles. The study evaluated the current state of risk management practices in building infrastructure projects in Niger State.
Yeah.
Are you hearing me, sir? The keynotes, the keywords are building information modeling, sir.
We saw that the slide was not, you were not moving the slides from our own end. And that's why we're asking you to wait so that we can follow you. You're on this, still on the first page. And so please take it gradually. Okay, and let's be wherever you are. Thank you so much.
Right, I think it's shared. You can see it now, sir.
Yeah, we can see it now. Go on.
Okay, so introduction. Building infrastructure project are key drivers of economic development in Niger State, Nigeria, contributing to transportation and essential services. Globally, structural risk management frameworks such as ISO 30,000 of digital tools like BAI and AI have enhanced project performance in developed economies. Literature review. Risk management essential in construction due to high cost exposure of environmental and political, economic, and environmental overrun, and project abandonment, with most firms relying on structural method. Secondly, development development countries enhance effectiveness through training, regulation, and digital tools like BIM, AI, and predictive risk simulation, enabling proactive and real-time decision making. Adoption of structural risk management system is shown in developed countries. Many construction firms lack formal risk plans, documentation, and continuous risk monitoring beyond the design stage. Next one. International conference. This one, what is this one? Research methodology. The study adopted a quantitative research design. One, primary data we are using a structural questionnaire with 4 sections: respondent demographic, risk management practices, effectiveness of risk management, challenges encountered. Responses were measured on a 5-point Likert scale: strongly disagree and agree, validity, reliability, and data analysis. Instrument validity and reliability were ensured through expert in pretesting. Data were analyzed using SPSS, applying descriptive analysis. Kai, oh God, yes, why is this guy? Kai, I don't know why this guy is doing like this to me. Kai, Findings and discussion. Findings reveal that the risk management practices are moderately adopted across construction organizations. The most common practices include regular risk assessment. The mean shows 3.06, and maintaining risk communication and reporting. By systematic risk identification and use of risk management software. However, as formal policy documentation, training, and clearly defined mitigation strategies remain weak, and that scores 3.0. The standard deviations averaging above 1.40 indicate considerable vulnerability. Next slide. Next slide. Next slide. The conclusion. This study examined risk management practices in construction and housing finance sector and found that while moderately applied, they are not fully institutionalized. Mean scores between 2.97 and 3.12 shows stakeholders recognize the importance of risk management in minimizing delays, cost, and safety risks, but implementation is limited by financial constraints, lack of skilled personnel, and resistance to change, weak regulatory enforcement, and poor integration of sustainability measures further hinder effectiveness. Strengthening institutional capacity, improving training, enforcing regulation, and increasing investment in financial and technological tools are essential for improvement. The last one, recommendation. Based on the study findings, several key recommendations are proposed to enhance risk management practices in construction and housing finance sector. 2, institutional and regulatory frameworks should be strengthened through standardized policies and consistent enforcement to reduce fragmentation in line with UN Habitat. 3, continuous training and capacity building for project managers and contractors are also essential, as adequate expertise remain a major barrier. Financial constraints can be addressed by improving access to affordable credit, encouraging government intervention, and promoting public-private partnership. The integration of modern technologies such as building information modeling, BIM, risk management software, and AI-driven tools should be prioritized to enhance efficiency and decision-making. Thank you for listening, sir.
Thank you so much, Mr. Ngozi, for the presentation. Now we listen to Mr. Moses' presentation. Are there any questions for him?
Or comment, yeah.
Question can come
I
up.
want to say that, please, we are here for conference. People must take feedback on. You know, we are here to get better, to become better researchers, either in terms of the way we do our research or the way, you know, about engaging the content of the work. I think it's good that people should go back better. So, as much as possible, maybe it's going to be 1 or 2 questions. Let it be something that will put the person in a very, you know, in a right position to do things better next time. So please, this person has presented, I know was rushing over some things, but I would like our professor to really engage him. Thank you.
Thank you, Mr. Moses.
Yes, sir.
Are you here? Okay.
I can hear you, sir.
Okay, well done. I don't
Thank you
know
so much,
what
sir.
level in your career. Are you a student?
Yes, sir.
Level, master's, PhD.
Masters.
Okay, so I want to encourage you that when you put up slides, particularly for conferences like this, you don't
Okay, sir.
read broadcasting.
Okay, sir.
Okay, I try
Okay,
to
sir.
speak.
Okay, sir.
Yes, which is probably due to network problems. I would like you in 1 to 2 minutes. Tell
Okay,
us
sir.
briefly what you did, what you found, and the implication of what you found. Thank you.
Yes, sir. It's all about risk management practices in our building construction in Niger State. Risk management is an essential component that need to be carried from time to time by assessing and mitigation. And from the overall discussion, we realize that we have weak institution that is not prioritize risk management practices in Niger State, especially in Minna, where we can overcome certain issues in building construction. And it has to do with cost overruns, delays in projects, and even the collapsing of buildings. That is why internationally, they developed a software called ISO 30,000. It's a software, and we have a BIM. It's a software equally that checkmates all the necessary areas in building construction that determine the success of the project and to minimize the risks of projects. So these practices are essential tool that helps the Nigeria, especially the case study of Niger State, to have a time frame for the project, to avoid cost overrun, to avoid unnecessary risks in the building construction. That's the aim.
Thank you. Thank you so much. Thank you. So
Yes.
one, the next question.
Thank you, Mr. Moses. In your
Yes, sir.
presentation, you talked about 5 scale, like a type something. So, and you told us that you talk about 5 scale of like a type questionnaire that talk about strongly agreed, and all those things. And you told us
Yes.
that you just analyze using SPSS. It's just a,
Yes.
it's a software. I want to ask,
Yes, sir.
what statistical tool do you now use? What statistical tool do you use in SPSS to get that result? Because SPSS is a package. So it's what to give it, it give you. So what statistical tool do you use? Because you have used you have talked about something like agree, all these items. So what statistical tool do you use in SPSS to get your results? Thank you.
Statistical tool, sir. Statistical tools are using mean, median, variance.
Thank you so much. Please
Are you hearing me?
request for the last one. Yes, we can hear you.
Yes, I said it's a statistical tool, but we use a mean, median, and variance.
Yeah, well done. So mine is not question pass, it's just in advice. So while you were presenting, you really have good things to say, but the way you were presenting it, you've lost the audience. And once you've lost the audience, definitely anything you are saying, people are no longer with you. So I want to suggest for next presentation I will be making, if it is virtual like this, it's important that you familiarize yourself with the tools that you will use for your presentation. So ensure that you are practicing enough and be the one in control, not somebody controlling for you. It will destabilize you. Thank you.
Thank you so much for please stop sharing your slide while the next one.
Next presenter.
Stop sharing your slide while we have the next presenter, please.
Hello, can I come up? I don't know if.
Dr. Jackson, please share your screen and start your
online.
Mr. Musa, can you stop sharing?
Dr. Jackson, please start sharing.
All right. Good morning. Good morning, pros. Good morning. Good morning. Good morning. Good morning. Please, can you hear me?
Share your slides.
Stop one or mute one better because the noise is moving. This. Okay, this is the Muntari Ibrahim, right? Dr. Jackson, where are you? If you are online, please say something so that we can be sure that you are with us. Okay. Is this Dr. Jackson? Okay. Thank you so much.
You should unmute
So
it.
please, can you put it
Okay. All right.
Presentation mode?
I've done that. Can you hear me, sir?
You are on two devices, and both of them are interfering with each other. You need to stop one, or you mute the other, so that as you talk, they will not. You are interfering. One is interfering the other. It's like you are connected on two devices, two different devices, and both of them are not muted. So the more you are using is what you should use.
I've muted one.
Oh, thank you. Well,
Can you hear me, sir?
We are getting feedback. If you have muted it, we will not be getting feedback that we are getting. Can you please either log out of the other? Maybe your speaker is on and all of that.
Okay. Sorry about that, sir.
Yes,
I've
you
done
are
that.
speaking to speaker, so we are not able to hear you. Can you talk to us now?
Okay. Can you hear me, sir?
Good. So now, can you put this on presentation mode, please? Just go to your slideshow up there. When you have home, insert, design, animation. Slideshow is the next thing there. Yes, put it on slideshow.
Okay.
Are you there?
Yes, sir. I've done that.
It has not responded here. Okay, so we have not seen your slideshow. It's not yet in presentation mode.
I've clicked on the slideshow.
Yes. From current slide. Now you see from beginning.
Okay.
Yeah.
Okay.
So click on from beginning or from current slide. Yes. It's like your laptop has a lot of load on it. It's just one. Okay. Yeah, already spending out of your 10 minutes.
So sorry, sir. All right. My name is Jackson Ande. Okay, can I resume slideshow?
Yes, do that.
Okay.
No, it's still not showing as presentation mode.
Ooh.
Okay, you know what? Just go on for now because of our time. The challenge is that we are not seeing this very well. Who
designed this flyer?
It's not clear. Even me that I'm very close to the screen, I'm not seeing this. Okay, Dr. Jackson is not there. Presenting again. Okay. Where is the last? Okay, who else is available? Let's just have whosoever is available. If Dr. Jackson is not ready, please just try to make your device ready for presentation. Put it on. Ensure you know how to put your device on slide mode, presentation mode, please, so that we can enjoy the presentation. All right, now we have any other person who is ready, available for presentation. Just share your screen.
Okay.
Yes, Ibrahim, let's have you.
I told him this
I told you not to use phone, and if you are using phone, ensure it's in. Don't show us PDF. We don't take it by standard. By our standard, we don't take it. Please take it down. Thank you so much. Montari, please go on. Thank you. Put it in presentation mode, like I said to the other people, please. It's either you do it up there or you also do it also down. You can just click on presentation mode. Or F5, yeah, don't press F5. Please say something to us. Are you there? Montari, Ibrahim, are you there? If you are muted, you can unmute yourself and let's hear you. We can't hear you. These are some of the things that actually delay the whole process, and then by the time we have our time spent gone, people will think that we are not giving them space. We say thank you. If you know how to do all of these things, or send it, please. Let's pay attention to it. When you are presenting, put your presentation have your slide in presentation mode, F5, or you go to slideshow and all of that. Either of that you can do. And then don't use phone for presentation. If you are using phone, ensure that it's in landscape so that we can see it properly in this place. Don't show us PDF, please. We don't want it. We don't take PDF in I think all these things have been communicated. And we are not getting through to any of these presenters. We will soon be going for our keynote presentation. So if you are not getting the online presenters to put things together, I wouldn't think that it would be nice for us to say that we are not giving space to talk. It's we that are not ready, not the organizers that are not giving us space to talk. Please. So put it in presentation mode. Click on slideshow or press F5. That would be that would be good for us. So if you are not doing that, you are not helping us. And you are also not unmuting yourself.
Someone is ready to present.
If you are ready, they should show. If you are ready, share your screen and go ahead, unmute, put it in presentation mode.
Okay, it's coming up.
Okay, good. So what's your paper code? Dr. S.A. Jim, what's your paper code?
My paper code is 21.
What's 21? Is it star APM or MLA?
Let me look at let me check, sir. That's APM 21.
Okay, now you may now go on with your presentation.
Okay.
Thank you. 10 minutes, please. Strictly 10 minutes.
Good day, everyone. My name is Dr. S.A. Jimo from Ashibas University of Nigeria. Today I will be presenting our work title, Fractional Dual-Damped Mathematical Model for Malaria Transmission via Crank-Nicolson Finite Difference Scheme. This study investigates how memory effect, intervention decay, and environmental variability jointly influence malaria transmission dynamic in Nigeria. These are the table of content. The background of the study. Malaria remains one of the most persistent public health challenges in Nigeria, but its transmission intensity varies significantly across the region and across season. In some parts of the country, malaria transmission occurs throughout the year, while in other regions, it appears mainly as sharp seasonal outbreak. These differences arise because malaria transmission exhibits strong seasonality, is influenced by delayed biological responses such as incubation and treatment delay, and often shows persistent residual infection even after intervention applied. Nigeria presents apparent ecological contrasts, like Ondo State, for example, is characterized by perennial malaria transmission due to favorable climatic conditions, while Borno State exhibits strongly seasonal outbreaks driven by environmental constraint on mosquito survival. Classical integer order mathematical models are limited in capturing this reality because they assume instantaneous transition between epidemiological states. Such models neglect the effect of past infection, biological memory, and the gradual decay of intervention effectiveness over time. To overcome this limitation, fractional calculus provides a natural framework that allow malaria dynamics to depend explicitly on their history, making it well suited for modeling heterogeneous and memory-driven transmission pattern in Nigeria. We have this prevalence, disease prevalence there. Also, related study. It is important to position our work within the existence literature. Classical malarial models, beginning with the foundation work of Rose and MacDonald, established the host vector framework and reproduction number theory, but they rely entirely on integer order dynamics and therefore neglect memory effect. Subsequent studies incorporated treatment, resistance, and demographic structure. However, these models still assume instantaneous transition and do not account for delayed biological responses on residual infection. Fractional calculus has been introduced in epidemiological modeling to capture memory and hereditary effects. And recent study have applied a fractional formulation to malaria transmission. While this model successfully captured long-term persistence, they generally do not distinguish between biological attenuation and the gradual deterioration and intervention effectiveness. On the other hand, climate-driven malaria model have demonstrated the strong influence of temperature and humidity and transmission, but this study are largely based on inter-order formulation and therefore ignore memory effect. This creates a clear gap in literature. Existing model typically treat memory, intervention decay, and environmental variability in isolation. The present study addresses this gap by developing a fractional dual-damped malaria transmission model that simultaneously incorporates biological memory, intervention deterioration, and climate-regulated transmission within a single stable numerical framework. Why do we use a fractional and dual damping? To capture this delay and memory dependent effects, we employ fractional order derivative, which allow current dynamic to depend on the entire history of the system. In addition, we introduce a dual damping concept inspired by structural dynamics. The first damping mechanisms represent intrinsic biological attenuation, such as recovery, mortality, while the second represents the gradual deterioration of malaria control intervention over time. Model structure. We formulate malaria transmission as a coupled human-mosquito system. The human population is divided into susceptible, infected, and recovered classes, while the mosquito population is divided into susceptible and infected classes. Transmission occurs through mosquito bites, creating a feedback loop between infected human and infected mosquito that sustain malaria transmission. Forces of infection. The force of infection for human depends on the number of infected mosquito, while the force of infection for mosquito depends on the number of infected human. This bidirectional transmission mechanism captures the core host vector interaction driving malaria dynamics. This now gives us the governing equation. So using a Caputo fractional derivative, we have this governing equation as represented on the screen. Here we present this governing equation. The equation accounts for recruitment, transmission,
4 minutes
recovery.
left, sir. 4 minutes, Mr. Jimo. 4 minutes left.
Okay, sir. So it shows the recruitment, transmission, recovery, warning, immunity, and natural mortality. The mortality, the key difference from classical model is that the fractional derivative introduces a memory, meaning the current rate of change depends on the past infection and recovery history. So we use a Caputo fractional derivative that weigh past change using a power law kernel. The fractional order alpha that is shown on the screen, it controls the strength of memory in the system. Lower the values of alpha, simply stronger the memory, and slower decay of infection. While when this alpha equal to 1, recovers the classical memoryless model. The D6 free equilibrium. This equilibrium represents a malaria free population state where no infected individual are present. The equilibrium serves as the reference point for threshold analysis and stability investigation. While the basic reproduction that we have there as R0, we use this as next generation matrix method. We derive this basic reproduction R0. Although the model is fractional order, this R0 depends on transmission and demographic parameters. The fractional order does not appear explicitly in R0, but it strongly influences the transient dynamic and persistence of infection. duodenum extension here to distinguish attenuation mechanism. We introduced duodenum acting on the infected compartment. The first damping parameter represents biological clearance, while the second capture intervention decay, such as the reduced net efficacy or drug resistance. The separation allows us to quantify intervention durability independently of biological
You have
recovery.
2 minutes left, sir. Can you move to your results and findings?
Okay. Numerical method for this problem. The fractional models involve non-local memory terms that can lead to numerical instability if not handled carefully. So we employ a Crank-Nicolson finite difference scheme that combined with Grudwald-Lennikov approximation, which provides unconditional stability and second-order accuracy for long-term simulation. We use calibration. The data that we got from the Nigeria Malaria Indicator Survey 2021, we consider Ondo State representing perennial transmission and Borno State representing strongly seasonal transmission. The simulation shows agreement with observed prevalence data in both states, as we have on the screen. The effect of the fractional order. Our results show that a lower fractional order leads to strong memory effect and slower decay of infection. As the fractional order increases toward 1, the system approaches classical behavior with faster decline following peak transmission. While in duodenum interpretation, increasing either damping parameters, any of the two, accelerate decay of infection after peak transmission. Mosquito side, damping produce stronger suppression of outbreak amplitude, highlighting the importance of a sustained vector control. The comparison between Ondo versus Borno. From the table shown, Ondo State exhibit higher transmission and weaker attenuation, consistent
Time
with
up, sir. Can you round up? Time up, sir.
Okay. The public policy implication, we have it on as shown on the slide. Disease overview and conclusion. Key findings. We have the following key findings. Fractional dynamic captured the effect. Also, lower fractional order prolonged persistence. Duodenum separate biological intervention deterioration, climate driving transmission, and also perennial regime. Strong agreement with NMI's data. From here, the model, the fractional duodenum model provides a stable and interpretable framework that integrates memory, intervention decay, and environmental forcing in malaria transmission dynamics. Results support continuous control in perennial region and seasonal targeted intervention in epidemic-prone area with periodic reinforcement to counter intervention. Thank you for listening.
For the presentation, due to the short time that we have, we just take one question. So please, if you have any question, please raise your hand. One question.
Thank you. All right. Actually, I just want to draw your attention to a few things as a way of getting feedback for what you have done. Number one, I want to say that you actually talked about an SER model, but in the end, you were talking about an SIR model, which does not capture the biology of malaria because there is an what's it called now? There is an incubation period for both mosquito and human. And then I saw you use mass action, for the force of infection for malaria according to its biology. No, that will not capture that. Mass action will not capture that. So you want to use a frequency-dependent force of infection. And I saw that you also created R class, the recovered class. Creating the recovered class means that either temporary, it means either temporal immunity or long-term immunity. Long-term will mean that if it's not returning to rest, what if it's returning to rest, there's temporal immunity, meaning that once somebody recovers, even with mosquito by that person, the person is not going to get infected within the window or the time the person is in the recovery class. Again, in the biology of malaria, that does not hold. Then I would be much interested. And then another thing I will draw your attention to is that fitting. I don't know how you get your house weight that's so high like that. When visually there is so much discrepancy between the data and the model itself, so much discrepancy, and the house weight that high. So I don't want to agree with that conclusion that there is a high agreement between the data and the model. It's obvious that it's not there. Then the question I would like you to now address is that you said you talk about damping something about you said winning effectiveness of either treatment or something. I think you are addressing a specific question, so you should tell us which of these did you actually capture in the model? Which of them ways that you consider? And then we'd like to see the effect of winning. Thank you.
Okay. Thank you very much for the observations. So we go over the code that we used. So the damping interpretation that we have there, what do we apply the damping? What if you look at the title of the work is on fractured duodamped malaria. So our area of concentration is on how the damp we have effect on that equation. So damping represents attenuation of infection intensity. So we apply it to infected compartment that reflect the biological and intervention driving processes that directly reduce infectiousness and prevalence. Applying damping to susceptible or recovered class would lack a clear epidemiological interpretation. That's the reason why we just concentrate on the damping. That's the sir. And the fractional order there on the equation.
Thank you very much. Please stop sharing your slides while we have the next presenter, Dr. Jim.
Okay.
Dr. Ibrahim, please, are you online? If yes, please start sharing your screen. Dr. Ibrahim. Dr. Ibrahim, please share your screen. Put your slides or presentation mode and start your presentation. You have just 10 minutes.
Just looking over my show. This finger, that's from this computer.
Please share your screen and start your presentation.
Yeah, just miscuts the
Who's the person? Sure, to send slide.
PDF, please start sharing.
This that's the so we must share that location for share.
And this person continue.
If
I've gone wrong.
look at shares system,
Hello.
your system.
Please start sharing. Accept PDF.
This is not
No,
PDF.
it's not PDF.
This is not PDF now.
Can we accept?
Okay.
You can accept this.
Yes.
Let's still continue presentation.
You are not finished.
Yeah, please start your presentation. You have 10 minutes.
Hello.
Please start your presentation. You have 10 minutes.
Hello, can you hear me?
Yes, we can.
Okay, good morning, everyone. This is Dr. Adeyi on the line. I'm here to present an abstract on the topic Gilaki numerous computational framework for dynamic response of entropic plates on Lasso foundation. Background of introduction. Several work have been done on plate model. Several researchers have worked on plate model, and several methods have been applied. Both analytical method and numerical method have been applied on plate model to determine the influence of some parameters that we have in the plate model on the deflection of the plates. So, but this work we want to apply a method which from the best of my knowledge, have not been applied to plate model. Actually, many researchers have used numerical techniques to analyze plate model to solve some plate model like Runge-Kutta. Many researchers have used Runge-Kutta as a time integration techniques to plate model. But in this work, I'm using numerous methods as my time integration because if numerical method can be used, I'm sorry, if Runge-Kutta method can be used for the time integration method, we can also use the numeric, I believe that we can also use the numeric scheme for the time integration techniques. It's just to transform the numeric method to a time dependent function. So
Dr.
what
Samuel.
I use is that hello?
Please, can you
Hello,
hear
can
me?
you hear me? Yes, I can
Yes,
hear
I
you.
can. Okay, please
Yes,
put
can I
your slides on full presentation mode. We can't see it.
on presentation mode?
Yes, put it on the full screen. We can't see it.
Okay, it's already on full screen anyway.
It's already on full screen, it's on presentation mode.
On full screen.
Can you try zooming? Maybe
You
should
can
zoom
click
in.
on a
Okay.
play.
Look, I should zoom it.
Yes.
Can you see it now? Can you see it
Yeah,
now?
better. Yes, better. And
Okay,
please be audible. We can't hear you.
okay. Like I was saying, many researchers have worked on this model using solve the model by using several methods, either analytical methods or numerical method. But as I said, there's many researchers have used numerical method like Runge-Kutta method for the type integration techniques. So I said that I felt that as a researcher, if Runge-Kutta method can be used as a time integration, we can also use another numerical method like Numero to solve as a time integration. So that was why I adopted Numero method as my time integration techniques to see if there will be any form of accuracy in the results. So the objective of this research is to formulate a rational model for an isotropic plates on Lasso foundation to discretize the model using the Larkin method, and again to enforce a mixed boundary condition, and again to solve the problem that is time dependent by using a numerical integration techniques or scheme. And after that, we carry out some simulations by varying some parameters that we have in the governing equation. And also consider the accuracy, convergence, and other factors. So the governing equation that we'll be considering here, which is the model, is what we have in equation 1, and other things are defined as we have in the equation. So the mixed boundary condition to be considered here is the simply supported and clamped boundary conditions as we have in the equation 3 there. So we move to the discretization. You know, this problem is a partial differential equation. So with the help of Gillikin-Risk model projection, we try to rewrite the governing equation to be a second order ordinary differential equation with the help of what Gillikin model, and we have in second order ODE, we have it in equation 4. So as we have there. So next thing now, the second order ODE that is gotten can be solved by using our number of techniques. So the number of techniques will be used here. This is a technique that is that is recurrent scheme that will be used to solve the the time integration, the second order that we have obtained. So numerous techniques is used because, like I said, many researchers have used longitudinal as a medical techniques to solve the plate problem. So I still believe that if longitudinal method can be used, we can also use numerous skin to still solve the same plate problem. That was why I said I should work on the numerous recurrent skin to see if it will work for the plate model. And when I tried it, it worked. So from there we have, like I said, we considered we are going to vary some parameters in the plate model because we are, as a structural dynamics, we are interested in the effect of some parameters on the model, like our plate model now. Plate can be any structure that is two-dimensional in nature, like example, bridges, like maybe slab, and so on and so forth. They are plate model. We believe that, and here we are considering moving loads. Some loads can move on the plate. What will be the effect of the load on the plate? So, and we have some parameters, like I said, we have some parameters in the plate model. We want to see if those parameters are varied, what will be the influence of those parameters on the deflection of the plate? Because we are interested in the deflection of the plate, because this will signal to engineers when they are constructing bridges, something that they need to put into places when they want to do some construction. That's why we are talking about deflection. If those parameters are varied, what will be the effect of the parameters on the deflection of the plate? So that's why we call the parametric study. And here we have the first one. Although there are many, but I only pick just because of this presentation. We have the longitudinal Young modulus. If this is varied, what will be the effect? We believe that as the longitudinal Young modulus increases, the deflection of the plate will decrease. And when the deflection of the plate decrease, it means that what? The plate will have what? We resist bending stiffness. That is, when the deflection decreases, the plate will resist bending stiffness along what? The S-axis. So we also have some other parameters like thickness of the plate. We believe that as the thickness of the plate, as the plate is getting thicker and thicker, it will also prevent deflection. No matter whatever work on the plate, it will have little effect on what? On the, or if it has little or no effect on the plate because of the thickness of the plate. So as the thickness of the plate increases, the deflection of the plate will reduce. This means that thicker plates are more vibration resistant and structurally stable. We also have other parameter we can consider. Winkler foundation. This parameter is also found in the model. We also believe that as the Winkler foundation increase in value, the deflection of the plates is what? Will reduce, and there will be what? Faster oscillation. This formulation acts like a vertical spring. What we are saying is that Winkler foundation. Winkler is the name of a scientist. That when plate model are formulated, he also has his own model. Winkler model. If you only have a Winkler model, we also have partner. Partner we have parameters, but Winkler only have one parameters influence on the plate model. We believe that as this Winkler foundation parameter increase in value, the deflection of the plate will reduce in value. So we also consider the convergent. Like I said, we consider the convergent study. We have the first one is spatial convergence. Spatial convergence is talking about space. Spatial convergence, we have this spatial error versus number of nodes. So we believe that you can see in the graph that from the graph, it shows that there is a rapid decay, right, for spatial error as n increase in value. So the spatial convergence is expressed using this one. This En is talking about spatial error, and we can see what the parameters mean in the question. And the other thing we need to consider is we also need to consider time convergence. The first one is spatial. The second one is what? Time convergence. We can see the graph here. Global error versus time. We can see here that this means that the global. Okay, I will soon be around. Thank you, sir. Thank you, ma'am. This means that the global error decreased roughly like 4 h raised to the power 4 as H is what? Half. This compound fourth order time accuracy. This means that every step time is half. The error dropped by what? 16 times. This may numerate at power second order central difference screen for vibration problem. So we also have the consistency and stability of numeroc. As we know that the local truncation error for numeroc is order of H equals 6 when applied, so that it is consistent with what order ODE. But the global order of numeroc is of order 4. So numeroc is consistently what unstable. So we can also compare. We also try to compare this with Runge-Kutta that is well known, where although they have the same order, both numeroc and Runge-Kutta have the same order 4. But numeroc is unconditionally stable for oscillatory ODE, but conditionally stable for non-linear system. While Runge-Kutta is continually stable. And we have the phase accuracy, we have the energy drift, and so on and so forth. So we also compare this numeroc method with Numa beta method. Numeroc method is of order 4, like I said, while Numa beta method is of order 2. And as we know that as the order increases, the accuracy also what increases. The accuracy depends that the order increases, the accuracy will also what will increase. So and we are told that numeroc is continually stable or continually stable, depending on the value of what of beta and gamma. And we also have the designing. We have oscillatory wave type problem. Numeroc can be applied to oscillatory and wave type problem, while Numa beta method can be applied to any general structural dynamics. While phase accuracy, we have it there. We also have the energy behavior and other things. So in conclusion, from our conclusion, we got that Villach-Numeroc formulation deliver a robust, accurate predictive tools for transient analysis of anisotropic plates on elastic foundation. Its enforcement of boundary conditions and preservation of bending continuity make it a well-suited for design studies and sensitivity analysis of composite and finally graded plate-like structures. So numeroc scheme provides superior stability and high order accuracy and improved energy preservation compared to conventional Numa beta integration and even Runge-Kutta. It's made particularly suitable for modal vibration analysis of anisotropic plates or elastic foundation. These are the references. Thanks for listening. I'm done. Hello. Hello, ma.
Hello, can you hear us?
Yes, I'm done with the presentation.
Thank you so much for the presentation, sir. Please, what is your paper code?
That is APM 08.
08.
Yes.
Okay, thank you so much. Please, are there any questions for questions, please? On the physical participant. Okay, in the absence of none, do we have any questions from the virtual participant?
Or feedbacks for him, the observation,
Thank you, Dr. Samuel, for your talk. From your statement, you mentioned that methods like Runge-Kutta has been used.
Yes. I've been using that method. Okay, sir. I can hear you, sir. I think I can hear you.
Okay. Like methods like Runge-Kutta have been used, right?
Yes.
As you mentioned. For the same problem, right?
Yes, for plate problem. Yes.
For the same problem, right?
For plate problem, plates, but not this same problem. I've not seen any work on this same problem. You know, in plate we
Plates
have
problem.
isotropic. Yes, plates problems.
Okay. Now,
Yes.
did you try that longitudinal method on this particular problem you have identified?
This one? No, I've not.
Yes.
I do the comparison because, like I said, in this problem, the recruiter is still used as a starter. Recruiter method is still used as a starter. We now proceed with the numeric method.
So when you use a longitudinal method, what did you find that was different or the same in this method?
No, this method, this method is the stability of the method, which you make different from longitudinal method. Like I said, when I was presenting, I said that I mentioned something that when we do some comparison, we have numeral. Both of them are fourth order, like longitudinal or classical longitudinal method. They are fourth order. But from what we observe is that the stability is unconditionally stable for oscillatory ODE, but conditionally stable for non-linear system. While longitudinal is conditionally stable, either is ODE or not ODE. That is what we observe. And in terms of face accuracy, we also have this method is superior to face accuracy. Although work is still ongoing anyway, more research is still ongoing on this method. So this is just for the presentation. We are still doing some lot of research to be sure of accuracy of the method. But because of this presentation, I don't have to come up with this, but we are still ongoing on it.
Okay, thank you very much.
Yes, sir.
Thank you so much. Please, can you stop sharing your screen? Okay, moving forward, we'll be going straight into the first keynote of the day that will be given by our dear Prof, Professor Olusoya Olubusoye, and his citation will be read by Mr. Precious Ojo.
I want to self-share it. I don't do affiliation.
To read the citation of Professor Olusoya Elisha Olubusoye, Professor of Statistics, University of Ibadan. Professor Olusoya Elisha Olubusoye stands as one of Nigeria's foremost statisticians and data scientists whose distinguished career spanning over 3 decades. He has significantly advanced statistical education, research, and policy applications across Africa. A scholar of exceptional caliber, he has demonstrated remarkable leadership in transforming statistical practice, fostering interdisciplinary collaboration, and building institutional capacity in statistics and data science. Appointed Professor of Statistics at the University of Ibadan in 2016, following his progression through the academic rank since joining the institution in 1995. Professor Olubusoye has established himself as a leading authority in econometric modeling, time series analysis, spatial statistics, and machine learning applications. His scholarly work bridges theoretical rigor with practical policy relevance, addressing critical development challenges in energy, economics, environmental sustainability, public health, and financial markets.
Professor Olubusoye research portfolio exemplify excellence and innovation with over 57 publications in reputable international journals. His work has garnered 1,396 citations, reflecting substantial scholarly impact. His H index is of 17 and I-10 index of 27 testify to both the quality and the quantity of his contributions. His research specializes in energy economics, petroleum studies, African development, and public health applications, with particular expertise in COVID-19 pandemic modeling and environmental sustainability. His pioneering work includes 1, developing novel methodologies for energy price forecasting using information-based uncertainty indexes with machine learning algorithm, advancing spatial regression and geostatistical methods for environmental and public health applications in Nigeria. 3, creating innovative approaches to algorithmic debiasing in machine learning experiments, providing empirical evidence for renewable energy adoption and environmental policy in Africa. Recent publications in high-impact journals such as Energy Scientific Report, Quality and Quantity and Applied Economics demonstrate a sustained research productivity and relevance to contemporary global challenges. Now, his leadership and institutional development. Professor Olubusoye's visionary leadership has been instrumental in advancing statistical education and research infrastructure across Africa. As the founding coordinator of the University of Ibadan Laboratory for Interdisciplinary Statistical Analysis, UILISA, he has built a premier center for statistical collaboration that bridges academia, government, and industry. Through UILISA, he has secured substantial international grants and partnership, including from USAID, MacArthur Foundation, and European Union programs. His administrative leadership extends his current role as Director of Directorate of Quality Assurance, DQA, at the University of Ibadan. He has also served as second Vice President of the Nigerian Statistical Association and holds chartered statistician status from the Royal Statistical Society, London. Currently, he is the president of Nigeria Association of Microeconomic Modelers. Yeah. His teaching excellence and mentorship. He is an outstanding educator. Professor Olubusoye has taught and supervised at all academic levels. His teaching portfolio includes advanced courses in Bayesian statistics, econometric methods, statistical data mining, and machine learning applications. He has successfully supervised 24 PhD theses, 22 MSc dissertations, and mentored numerous early career researchers who have gone on to distinguished careers in academia, government, and industry. His pedagogical innovation extends to developing specialized training programs for the Central Bank of Nigeria, where he regularly facilitates workshops on big data analytics and machine learning for monetary policy. His commitment to statistical literacy is further evidenced by his popular radio program, Data Speaks, on Diamond FM, which brings statistical concepts to public audience. Professional and recognition service. Professor Olubusoye's expertise is widely sought both nationally and internationally. He serves as an external assessor for professorial promotions at numerous universities across Nigeria and Ghana, including the University of Ghana, University of Development Studies, and Tamil Technical University. This appointment reflects the high regard in which his academic judgment is held. His professional service includes membership on the Central Bank of Nigeria's Technical Working Committee and the Certification Committee of the Chartered Institute of Statisticians of Nigeria. He has also served as a consultant to international organizations, including the African Union Commission, World Bank, and African Development Bank, contributing to policy formulation and capacity building across the continent. Now, his awards and honors. Professor Olubusoye's contributions have been recognized through numerous awards and honors. There are many, but including some of them are first, Microsoft Research PhD Fellowship as Supervisor of Awardee 2021. International Statistical Institute Statistical Capacity Building Award 2020. Elected member, International Statistical Institute 2019. Exchange of Visitor to LISA, Virginia Tech and Purdue University, USA 2016. Visiting Scholars, International Monetary Fund, Washington, D.C. 2006. Multiple research grants from AERC, MacArthur Foundation, and USAID. Legacy and impact. Professor Olubusoye's enduring legacy lies in his transformative impact on statistical practice in Africa. Through his research, teaching, and institutional leadership, he has elevated the standards of statistical education, fostered evidence-based policymaking, and built sustainable capacity for data-driven decision-making. His work exemplifies the highest ideals of academic excellence, social relevance, and professional integrity. As Africa confronts complex development challenges in the digital age, Professor Olubusoye's contribution provides essential tools and framework for harnessing data science and artificial intelligence for sustainable development. His career serves as an inspiring model of how academic expertise can drive positive transformation at institutional, national, and continental levels. With joy in our hearts and with a clapping ovation, join me as I welcome a scholar of distinction, a leader of vision, and a mentor of exceptional dedication, Professor Elisha Olubusoye. You are welcome, sir.
Please be seated.
Slab every fire.
Yeah. Between morning and afternoon. Good day. Let me start by thanking God and of course thanking Professor Bakari for giving me this very rare opportunity to be here. I also want to thank very eminent professors here, Professor Okoya, Professor Mrs. Okoya, and Professor Temidayo Apata. We've been together for quite a while. Only that you disappear from the radar. Now you are found. Without wasting time, I would like to take us through a journey. That journey will take us from this knowledge of model to decisions. And that journey is also the same thing as saying the journey from the static point to the dynamic point. Because the word is, I will explain more as we go on. But basically, I want to drive home the point that we are in the world that is driven by data. That the modern the two things actually drive development in this age. One is technology. The other one is data. And these two, they go together because technology actually helps to generate data. When you see traffic light, in some cases, sensors and so on like that, even your phone that you carry is a technology, but imagine the number of pictures you have taken this morning, today, or since this program started, the number of messages that you have sent. So technology is a major driver of data. And it has also led to a shift. So I will be discussing about the shift with the real world, that shift from evidence, from risk, from fraud, from energy, or anomaly detection. So my overall goal actually is to show how machine learning in particular is not just a tool, but is a paradigm shift. That machine learning that we keep on talking about. So it's a paradigm shift in how we move from models to decisions. So in my talk, I will start by tracing the theoretical evolution of applied mathematics. Don't take me as an authority in this area. Professor Akoya is the authority, but I can lean on his shoulder to say some things. So I will just say a few things about that theoretical evolution. Then I will discuss the transition from model to decisions. And then how output from our models can form the basis for actionable insights. Our model is not just to run model, but it's supposed to take us beyond the result to taking actions. And so I will demonstrate with 2 case studies, but because of time, I might skip one of them, one to save time. But the one that may interest you is the second case study, which actually has something to do with the University of Ibadan regarding energy anomaly detection. Then we would touch on responsible decision makings. I will conclude with what I consider to be the future directions. Now, historically, applied mathematics was built on what we call classical paradigm. And that classical paradigm is defined by these 3 things. Theory first, assumption heavy, which brought proof yesterday. You have theory, so you are sound in the theory. And then have very rigorous, sometimes difficult assumptions. And like Prof said yesterday, the idea is to simplify the problem. So that's where we were coming from. The other thing that defines that classical is that we were always after closed form solutions. These models were elegant. There's no doubt about that. But unfortunately, they are fragile. Why are they fragile? They are really updated. And they are prone to what we call model decay when they face a dynamic environment. And when we say model decay, I will try to explain most of these concepts for everyone to understand. When we say model decay in dynamic environment, we simply mean that a statistical or a machine learning model performance deteriorates over time. That you build a model today, over time, the performance of that model, if the model is not maintained and updated, the performance of that model will deteriorate. Why is it deteriorating? It's deteriorating because the real world data that we use, we always encounter changes. And that changes is what we call concept drift. Concept drift. So when there is a change, the way we used to, we've talked a lot about many things. The way we do a lot of things has continued to change because of technology, for instance, which I mentioned. So to address this concept shift, we are now moving from the classical paradigm to what I now call the modern shift. And the modern shift is when we adopt adaptive learning system. Adaptive learning system is one that learns from data in real time, unlike the classical where you already have a closed form solution, which is also not capturing the changes, the shift, the concept shift that I mentioned about. So the problem is that the classical often assume that the world is stationary, and the world is not changing. But the current shift is acknowledging the fact that the world is in a continuous change. So the life is changing. I hope I'm communicating. So the question is, what are the drivers? What are those things causing this change? Why this concept shift from classical, right? No. To the modern. Why? So 3 forces can be attributed. Maybe all other forces can come under. First is the explosion of data. We are no longer dealing with small data. We are no longer dealing with curated samples. But like all of you will define big data, we are dealing with high velocity multidimensional data, whether in the cell, genetic, wherever, you are dealing with very massive amount of data. So, unlike before, you handle very limited amount of data, which you use your calculator or the logarithm table at best, and then calculator, and then, now. The other thing that is bringing about the change is the computing power. The development of graphics processing units and parallel processing enable us to solve optimization problems that were not were difficult previously, if not impossible. So GPUs, they are the hardware engines behind the fast and large-scale machine learning and real-time analytics that we now do. The third reason for this change is the fact that data are coming in real time, and decision makers, businesses, institutions no longer want monthly report. They want on the spot information to make decisions. So they need millisecond level decisions. So this trial has reshaped what's possible in applied mathematics. So applied mathematics, of course, most people will also classify statistics as applied mathematics, fine, but it's about data. So let's contrast the theoretical evolution with, or rather, let's contrast the tradition and the modern. As a matter of fact, the transition is what I call the solver era. That's the time we look for closed form solutions. And the modern is what I call the architect era. This is very important for us, those of us that are just coming, to understand that we are in a new era. We are coming from addition, and we are in a completely new situation, new world. So we can compare the two. In the solver or in the traditional era, as I said earlier, focus is on closed form solutions. We use p-values a lot. How many of us use p-values? We use p-values a lot. In fact, I've had to give a talk on significant or not significant, the controversy surrounding p-values. When you hear most studies, in fact, people have, so many researchers, they have won laureate because of p-value. But now we discover that most of the studies that made them to win those laureates are not reproducible. The p-values are not reproducible. And science, one of the hallmarks of science is that reproducibility of the study. If you start all over again, you must be able to the same result, get the same result, and also arrive at the same findings. It's been discovered that in the traditional era, we brandish p-values. Even in some of our departments, as it's still about, is it significant? Is it not significant? But we are moving beyond that. We also look at goodness of it. Seen many presentations, AIC, BIC, yeah. So models were static at that time and manually calibrated. Today, in the architect era, we prioritize predictive utility, flexible algorithms, and continuous feedback. Those are the hallmarks of the modern era. So we moved from proving theories to optimizing decisions. The measure of success is no longer just statistical significance. So we emphasize on practical significance. So when I teach now, I make distinction between statistical significance and practical significance. There is a wide gap between the two. Can be statistically significant when it does not even have any practical significance. And a very common example is, I don't drink beer, for instance, but suppose I'm forced to drink, maybe one bottle will make me go intoxicated, right? Maybe one bottle will change my, thinking system. That would be very significant. But when you now, for somebody who can drink a carton, and one bottle be significant. So when we bring significance, we emphasize not on the statistics, I'm a statistician, not on the statistical significance, but on the what? So our emphasis is the measure of the impact. So even in statistics, we talk about effect size. We talk about effect size. Sorry. It's not responding. Okay. And this is very critical, very important. I've talked about the shift, but I want to also lay emphasis that despite the shift from theory first to data first, the foundations remain deeply mathematical. Did you hear me? Yes. The foundation, what? Deeply remains mathematical. Despite that, we are shifting. There is a shift from theory based to data, theory first to data first. Optimization, for instance, gradient, descent, convex optimizations, power line, all of that, that we use in machine learning, they help to find the best model parameters that minimize error loss or maximize performance. So we still use all the optimization techniques, but now is to find the best model parameters. 2, we still use our linear algebra, whether we are using singular value decomposition or matrix factorization. We use them to help us navigate high dimensional spaces. We still use probability, and we've talked about this. Bayesian inference, uncertainty quantification, all of this allows us to manage risk. So let me put a sound of warning that machine learning is not a departure from mathematics. I hope we agree. It's not a departure. In fact, the foundation is what? Mathematics. So we can conveniently, without enduring anybody's that it's an extension to into it's an extension of into data rich domain. Machine learning is an extension of mathematics into what? Data rich domain. That is how I want to see it. And that takes us to where we are going. Once I give this foundation, I will take the application and we are good to go. This is the chain of action from models to what? Outputs, and from outputs to decision. This is the core of our talk. This is the core of our discussion. How we move from building models to making decisions. Models like anomaly detectors or forecasters, they produce structural signals. Some of them will give you, for instance, risk scores, alerts, and intervals. Those things are calling for actions. When you have a model that is giving you signal or giving you the measure of risk and so on. So those actions from the output, they are often operationalized into automated actions rather than just getting the output. The actions are also automated, that once you have this value, then alarm signal should flow. Are you with me now? That's the state that we need. Once a car, maybe you put your sensor at the gate and it's automated, and or you go to a bank and you want to apply for loan and you submit your details, and the system, the machine learning, the algorithm runs on it, and quickly you see the decision. You are not eligible to apply. Or you put your card into the dispensing machine and say, the alert is given at the back end. This card is stolen. You are at the airport, you suddenly, if you have been traveling at the airport, among hundreds of thousands of travelers, you don't say, Olubusoye, Olusoya, Olubusoye, report so. Your baggage has been scanned, your visa has been scanned, everything, in fact, but they have isolated your luggage. Are you with me? This person should be properly screened. Then humans will now come and do the screen. That is the hate. I hope you are getting the communication. So that is the hate we have. What do you think is working on that net? It is the algorithm. And you don't have to wait till next week before you know a traveler, a suicide bomber, already body or boarded before you now start looking for what solution. So if you are thinking of any problem right now, it's a problem that we take you from model to output to what? To real-time decision making. Then you are contributing. That is where we are going. That is where we should be. That's where we should be. And this is when this pipeline model output or decision, this is when it turns our analytics into something that is valuable. Turns our analytics into something that you can take actionable insights. So, with that background, I will, because of time, skip to the example that I want to show, and then we so I'm going to skip this. Yes, this one should interest you, and it's about electricity consumptions anomaly. For some time, I'm sure you've heard about universities groaning, complaining about the energy cost, how much they pay to the discos. UI at the time also was under that serious burden. So what we did was to gather 12 years of smart data from the University of Ibadan residential areas. And we were able to gather transaction data for 138,310. We focused only on the residential areas. And the issue was that it was discovered that in some residential areas, people were even bypassing professors bypassing energy, not to pay. The same thing with non-academic, you go to, if you know Abadina area and so on, they bypass electricity. So a lot of sharp practices were going on. So that led to this. Actually, this study was done by one of my master's students, and the university cooperated. And that's why we were able to access the data. So the scale of this data set is substantial. If you look at the total amount involved in this transaction, how many of you have this in your account? 449 million. That's the amount involved. And we found that on average, 1,528 transactions were made. You know what happened is that customers, they come buy the units and load on the digital meter. And on average, 4 million or close to 5 million was realized. So this represents significant energy consumption. And if we are able to optimize, that will yield substantial cost saving and efficiency improvement for the university. So our goal was to detect anomalies like meter tampering or billing discrepancies. That was the main objective. So we applied, these were the methods we applied. The set score, that is standardized score, the interquartile range, that's IQR, the dB scan, density-based spatial clustering or applications with noise, isolation for rest, and then we use R and Python for the implementation. So, different methods, of course, from the table you see here, different methods actually yielded different anomaly rates. For instance, the Z-score yielded 34.93%, 14.95%. The standardized score yielded 39.93% with interquartile range. The consensus approach yielded 22.11. So we use the TSNE visualization. TSNE is T distributed stochastic neighbor embedding. So this layered of approach, you use multiple approach. The objective is to ensure robustness of our findings. And the TSNE visualization provides an intuitive way to understand how anomalies differ from normal consumption patterns. If you look at it, maybe from where you are seated, you will see some spots, red ones, and you also see the hash ones. So the red points suggest that you can see the scattered nature of the red points, and that suggests that diverse types of anomalies rather than a single pattern of irregular behavior. So seeing them being scattered is saying that the nature of the anomaly is not unique, that different anomalies, different approaches are used by the customers to beat the system, to be able to avoid paying for the electricity they consume. So it's not one approach they use. That's what that scatter point is. So, and the advantage of using this type of visualization is that it helps energy managers to quickly identify which account warrant immediate attention or not. You will also notice here that we have the electricity clustering behavior. We have different clusters depicting the electricity consumption pattern. We have over 90 accounts in cluster 1. and those represent group of electricity consumers with high consumption level. So we are able to categorize them. Then we also able to categorize 2, 2, 4 as moderate electricity consumers. And quite a big, a good number, 1,097 happen to be low consumers. So this group represents different behavioral groups of electricity consumers at the University of Ibadan. So you have high consumption consumer, moderate, low, stable. But before I leave that, maybe you will notice that the clustering revealed that most accounts fall into low, which I mentioned, which is expected for residential settings. However, if you look at the high consumption, they also have high variability. And this is interesting. The fact that they have high variability, this could be accounts with unusual usage pattern. There are potential, group to monitor. They could be commercial, they could be doing commercial activities, even within the within the resident. Maybe they are grinding pepper, using a shop, hot later. So, but what this will help the authority to do is to identify those groups and then track them and do further investigation about their activity. They will need to know, but behind the algorithm will always be showing, these people should be investigated. So we use multiple validation methods, as you can see on the screen. The idea of validating is to strengthen the confidence in the result, particularly in the 3-cluster solution that we arrived at. You will see the able method shows diminishing returns beyond after 3 clusters. You will see after 3 clusters, this is the one, and this one, after 3 clusters, you can see the plot going down. So the box plot clearly demonstrate how those in cluster 1 accounts differ dramatically from other groups. If you look at that's the left. This is the cluster. You will see these are the group in cluster 1, and all through they show they are different from the remaining other 2. They show different behavior from the other 2 groups, and that put them on the suspect list. Okay. Not only do they have higher average consumption in terms of median, but they also, in terms of the variability, they have more transactions. Variability is measured by the size of that, because it's looking at the range between the upper quartile and the lower quartile. So this pattern could indicate multiple residents sharing a meter, irregular occupancy pattern, or potentially unauthorized usage that merits further investigation or detailed auditing. And we also, I think I've spoken about this. This is the final, well, so to say, output. We then listed the 52 accounts that we found to be anonymous. And these are the accounts. If you live in UI, maybe your account is there. So, but what are we trying to say with that? Your model should lead to actionable insights. That's the bottom line of this presentation. It shouldn't be so dicey, so crowded. You cannot, the policymaker is not able to see what action should I take now? What should I do now? When you have used battalion of techniques and models and approaches, yes. At the end, you remember the pipeline from model to output to what? The decisions. That's what and then in yes, what's happening? So these are the key findings, but I'm not going to, some of them we've discussed, so to save our time. So that takes us to the most important part, and that is the human in the loop and governance. All our model must have the human factor. Animals will not run the model. Animals are not the ones that will take decisions. Human beings are the ones. They are the rational. They are the rational beings. They are the ones who can think, who can know. So whether in fraud or energy, decision must be responsible, which means we must maintain human in the loop system. Experts will review high-risk flags, escalation pathways. Every decision is carefully documented. Every step, every stage. I always, of course, I think we've talked about it, reproducibility and replicability. These are the core, features of science. Models are auditable across versions. You can always have version of your model. So not that you have one model today, you can always, even those in technology, you upgrade, isn't it? You upgrade our phones, you upgrade from laptops, but you must that is maintenance. Keeping your model very active. If you are building model, today you build model for malaria, tomorrow you are building model for typhoid fever, next today because if you keep on building models, like I said earlier, all those models will suffer decay. They will deteriorate in terms of the output they will be generating. And that's what's taking us from the old era to the modern era. Models are auditable across versions, so it's not just an ethical issue, it's the operational best practices. So, what should we look forward to? What should we expect in the future? Looking ahead, I can see three key directions. One is graph-based learning. Two is online learning. And three is connected, adaptive, governed system that operate end-to-end. The graph-based learning will detect coordinated fraud through rational networks. You know those fraudsters. Fraud is a real event, right? out of all of us, there are those who will likely perpetrate fraud, maybe just few. But it's also a racket. It's not only one person. Sometimes we need a model that will be able to connect and coordinate networks. Are you with me? If you are specializing in fraud detection models and things like that, then online learning for real-time model adaptation. The purpose of the online is to allow your model to adjust quickly so that there is no lag. Because we are all operating now on two spaces. We are operating on the physical space. We are also operating on the virtual space. Two of us. If you are still only in the physical space, we've taken your position in the virtual space. Because I used to, when I talk to my colleagues in Nigeria Air Spaces, who is occupying our space in the space? Maybe those who are there first, they have already done the CFO. So we are not in a hurry, but they are there. They have marked every place, including our own. So when we are ready and we now get there, we have been here before. So the future is not just automated, it must be intelligently adaptive. It's not just to be able to detect, it must also be able to respond to emerging threats. Because when you have a way of practicing fraud and you are detected, people change. They change quickly. And they are so gifted. So gifted in the way they change the whole thing. If your model is designed only to detect old habits, when the new habit comes, it's obsolete. It's obsolete. So to summarize this lecture, applied mathematics is evolving from static models to adaptive, data-driven systems. Machine learning enables us to make real-time, high-stakes decisions in domains like fraud, energy. Not only there are so many areas, but with this power comes responsibility. We must, in fact, in Europe, all these algorithms, all these things, when you build your algorithm, you must be responsible. You must take responsibility of what happens. That's where, when you are using some of these applications, you see full disclosure. If you are now ready, you click yes, you subscribe. Once you tie your own hand, but taking responsibility is very important. So you must be, the model must be, that's why we talk about explainable AI. Not one that you cannot explain how data enters and how output comes out. So there must be oversight. That's the essence of the human. There must be governance. Governance that are non-negotiable. The case studies today show that this shift is not just theoretical. It is delivering tangible impact. And I think on this, I want to say thank you. Kind attention. If you have time, please, you can visit my YouTube channel. Just Google for Olusoye Olusoye. You will see quite a number of videos there that can help you. for those who are, wants to know more. Thank you very much.
Please, can we put our hands together once more? For me, you would agree with me that you can give a standing ovation if you want to do it. Yes. You will agree with me that this is a very powerful presentation. Very powerful presentation. Now, as a mathematician, for me, please you can see that things that stood out for me, it took us from knowing that we were in the era of theory first to the era of data first. Is that not? It's not era of data first. Is that okay? That we have also moved from the era of proving theorems to the era of optimizing what? Decision. Is that okay? And he has also reliably told us that even though we have moved from that era, but the foundation still heavily rely on what? Mathematics. And then you saw how he demonstrated, a problem in energy to real decision that has to be made. I think for me, that is where we have come to. And except somebody wants to remain obsolete and remain in the Stone Age, that's when all these things that we have started hearing from Monday, right, will not enter into your subconscious, your fabrics, and you begin to do something different. Please appreciate him for me again. Thank you so much. Somebody was saying beside me while they were saying, he's a teacher. Because he just was moving slowly and was entering into every fabrics of your being. No, this is very powerful. Thank you so much. Thank you. Now let me allow questions. Questions, both physical and online. Of course, we expect it. So we just so I'm going to give you a number. In case there are people online, please signify, let me know. So Mr. Oakland 1, and then my brother over there 2. Okay, then 3, 4. So we have to be fast. Oh, Prof must. You know what? We'll take it. We will take it in ascending order, so that finally, when we get to the peak of the whole thing, so I will allow Prof to just still enjoy others and ask the question why it takes the final one. So can I have you from there? Okay, yeah. I've picked number 1, 2, the other 2, 3, 4. Then Prof. I'm not giving any other number after now. Thank you. Okay, can we go on now?
Thank you, Prof, for this lecture. I'm highly moved by what I've heard from you. I have some questions. The first one, you talked about the statistical significance, which used to be, and we should be talking of practical significance. My question there is there any intersection? And then the second part is the example you gave in UI, electricity example there. And I want to say that I don't know, here in Nigeria, even the man who gives the rules sometimes doesn't keep the rules. I'm just giving a situation where, for instance, you are ready to pay for the bills. And then after speaking, you are free with food items. The light doesn't come for 2 weeks. And so what would have taken you for 2 weeks is destroyed. So it makes you say want to cut corners. So I don't know if there is any way to talk to the person who makes the rule to see how I can give to the rule. Thank you.
Sure, because anyway, Prof, before Prof answer that question, while that presentation was going in, key figures in our dear universities came in, and I must recognize their presence. I can see here now the presence of our own HOD of Department of Mathematics, Federal University of Ekiti. Professor of who came in while the talk was going on. Thank you so much. And it was accompanied by Dr. Salahuddin and Dr. Adawa, also senior lecturers of that great department. And we're happy to have you around. Thank you so much. It's an honor to have you. So Prof may now answer the question.
Thank
don't
you.
cut corners.
The question, the first one, is there an intersection between practical significance and statistical significance? Ordinarily, if you go by the principle of statistical inference, you start by choosing your level of significance even before you start collecting data. Your level of significance, which is alpha, is the one that you have chosen yourself to say, I find this, so whatever finding I have, if the alpha is 5%, then I'm only ready to accommodate 5% margin of error. In other words, I'm ready to reject my null hypothesis when in fact it is true. I don't think you are following me. Am I complicating things? Okay, so when you choose that level, is the level of doubt you want to have concerning your findings. That is the layman interpretation. That's the level of doubt you can tolerate. That's why in medical sciences, you raise that percentage, or you that confidence, you make it 99% and just allow for 1% level of doubt. So when human life is involved, you want to make, if possible, 99.9% level of confidence and just have very small level of doubt. Then after you have chosen that, the next thing for you is to formulate your hypothesis. After formulating the hypothesis, then you go and collect your data and you compute your test statistic, Z, T, and so on. The last stage is where you now take a decision. And what decision you are taking is simply to compare the p-value which is coming from your data with the alpha value which you have predefined. Are you communicating with me? Which you have predefined. So if the alpha value is smaller than the p-value, that's when you say it is significant. Right? If the p-value you obtain, if the p-value you obtain is smaller than the alpha value, that's when you say it's significant. In that case, you reject your null hypothesis. Is that okay? That is the connection. And then you say it's significant. But the fact that it's significant could be attributed to a number of factors. If the sample size is large, it could be significant without necessarily making any practical impact. So we usually discourage you making your conclusion. You will stop there. You will make your significant or not significant. You will take that decision. But it's not, you will now go step further to do effect size, to also use confidence interval. Because p-value is a single value. And when you use single value, if you collect another sample next time, you won't be able to get that same p-value. One sample that you take at a point is one out of several millions of possible samples. And as you change your sample, the p-value also what changes. So it's not reproducible. But confidence interval, you are confident that if you repeat this study 100 times, if your level of confidence is 95%, then you are saying that out of this 100 times, that result you'll be within that interval 95 times. So that way of taking decision is credible. If you also don't want to go Bayesian, the beauty of Bayesian is that you are now able to measure the uncertainty associated with your findings. So your finding is quantified in terms of the uncertainty, which is better, unlike the classical statistics, which you simply say go, no go. Huh? Guilty, not guilty. And so on. I hope that helps you, but if not, we can continue outside. The last one is about outages and that pushing you to cut corners. First of all, the study, our father or parent used to say that when the house is dry, everybody is a thief. So first of all, in modeling, everyone is a thief, is a potential fraudster. Nobody is this thing. But your record will show, right? So in modeling, you can do modeling for exploratory, for diagnostic, for predictive, for prescriptive. Do you get me? For exploratory,
yes.
For diagnostic,
for predictive,
for prescriptive. We don't, otherwise I will start another round of But the point is that we are not, outages should not be the cause for anyone to cut corners. You are looking at it from the consumer point of view, but this study is about the institution supply point of view, that we're supposed to hand this revenue from energy consumption. Are you with me? And therefore, are we optimizing our revenue? And who are those cutting corners? It doesn't matter whether they are cutting corners because of outages. If there is no grid supply and you do your own solar distance, will you be cutting corners? You'll be shooting on yourself. It doesn't. If you have your this thing, you won't. It doesn't make sense. But the study is from the supply perspective, not from the consumer perspective. The consumer can also do modeling to understand power. Like I asked one of my students living in the house of residents to monitor daily power outages. Anytime they take light, she's going to record. And when they bring it, it's going to record. During the time when there is an outage, she's going to ask people what alternative energies they were using. So maybe they have power bank, maybe they put on other generator, maybe whatever. So she also tried to monitor the coping mechanism used, and so on and so forth. That's from the consumer point of view. I hope that helps.
Thank you so much, sir. I think maybe after now, Mr. Alba may want to take another PhD study for the consumer people. He likes to fight for them. Your model will help them a lot. Thank you very much, Prof, for the presentation. I've got 2 or 3 questions.
So, are you smart?
I'll check.
Oh, no.
Okay. My first question is a bit naive. Question is about how much data is too much data.
How much data is too much data? And that is, I can give you a quick answer to that. There is no too much data.
Okay, that's a very good.
I can give you a very simple example. Have you seen me before? Right? You've never seen me before. Or if your wife abroad, you've not seen me before. But if you've been hearing about me, right? You have data about me. That's what that means, right? Somebody can say the head is big. That's the only thing that person could see. Another one could say the man fat. That's what you could see. And then you start compiling the data, the head, the face, the hand, the color, the weight, the gender, the zone, everything. You will never have a perfect information until you. Will you? Even if you have all the pictures of all the information about me, you will see me, everything. Yeah. If my mother woke up from the grave and described how I was born, everything, you've not seen me, right? You've never seen. Unfortunately, the result we are looking for, nobody will ever see the result. So we talk about the truth, the fact, and the falsehood. The truth, the fact, and the falsehood. If the truth is what nobody knows, you don't even know the truth about yourself. Unfortunately, and your wife does not, when she doesn't even know about herself. So we are all looking for the truth, but we only have access to fact, numbers and figures. That's why the fact of today can change tomorrow. It depends on the, but the truth is constant. Unfortunately, nobody knows the truth. That is why you can never have all the information you need. Till tomorrow, we will continue to do research, continue to dig and collect more data. What study are you doing that somebody has not done before? Huh? But we are still, that's why it's called research. Search, research. So it's no data is too much. That's why even we are even now in the age of big data, right? Still, big data is not even all the information.
Thank you very much, sir. I really appreciate it, sir. I have many questions too, but the one for everyone is that when you said you gave a talk about significance, PE values. Yeah. Now you said you have it somewhere. Can we have the link or where it is so that I think can learn?
Yeah, I can share the slides with you.
Okay, that's
I should also have it. Yeah, which I will share. Then
I like people that don't.
If you go to my YouTube soon, you might be able to see the video. I have another lecture webinar this month, maybe next week, on modern sort of. I will share the flyer.
Okay.
Please try to join.
Okay. Now, you know that I wanted our dear prof to wrap up everything. I mean, that's Professor Koya. So for that, I was told that there were 2 people waiting online.
Wow.
So so that they won't say we are silent. So online participants, please, if you have a question, can you unmute and just ask a question? One question. Thank you. Can you unmute yourself? One. I'll just count 3. Okay, Alushi, are you there?
Yes, sir. Yes, sir.
Okay, go ahead. Just one question. Be brief about it, please. Thank you.
Okay, sir. My question goes like this. Mine is coming from the aspect of the data first. You know, where the way he was talking, the prof was talking, I get to understand that the reason why this thing we lack impactful research is because the lack of data is somehow. So I want to ask, sir, what are the ongoing efforts that you or maybe I want to know in Nigeria currently that, about availability of data, so that people like us who are also going into research and, going deep into making research impactful, and we can also have access to data and then bring up something. I think that would be the question I'll ask now, because I have many.
Okay, thank you so much. We got your question already. Well captured. Thank you, Prof. Will respond.
That's a $1 million question. If I have $1 million, let's think about two things. Data. Because I've worked with government, even statistician general, we've had a lot of, even at the continental level, data is a serious issue. So I can't deny that fact. And you can't wait until you have data, all the data you need, before you can do research. So what I encourage is that whatever data that is available, work with it. That is one solution. The other solution, like a colleague was making a presentation about malaria yesterday. Prof. Mrs. was there. Was it yesterday? Okay. So,
Day before yesterday.
Yeah, day before yesterday about malaria. After the presentation, we now discuss, and I got to know that, you work on Samfara. Nasarawa, and so. Now, the first thing I noticed was that these are nationally aggregated data. And he also told me that Samfara has the highest cases of malaria in Nigeria.
I think it's a one.
And use that as one of the justifications for the choice of Samfara. Now, what am I driving at? The point is this. For a long time, I've stopped having confidence in nationally aggregated data. In economics, we call it macro data. If they ask you now, what's Nigeria GDP, they say we are growing at a certain rate, but everybody is complaining, no money, no money, no money. So aggregated data masks, it covers a lot of, but it doesn't reflect, because that thing is, if there is only 1 millionaire here and all of us are having 100 and so on, by the time we aggregate our income,
take the lead.
They will say we are rich. But 99% are actually what? Poor. That's what happens when you have nationally aggregated what? Data. So I always encourage students that don't go for, because your question is about expecting government to produce the data you need, but rather you could also produce the data you need for your study. And instead of you covering large areas, and I've faulted a lot of supervisors, they just want, they will say, you are covering only Ibadan, you are covering only Oye, it should be Nigeria. This project is not funded. And the aggregate, the national data you want to rely upon, they are not all that, they don't reflect the reality. Why not cover a small area and study the in depth? Make it small, but study the area deeply. Your findings will be more impactful. This malaria thing you are doing, why not cooperate or go to the health centers, primary health centers around here? Every day you will be recording, collecting data about malaria cases. If they attend to 10 people today, you will be able to know what proportion of those attended to are malaria cases. Are you with me now? That your result will have impact on the community. This thing you are doing is national. They won't even see your results. It won't have any you can publish or maybe for academic purpose. But if you want an impactful, life-changing result, you have to work with your community. In our lab, that is what we are doing now. We are monitoring, doing price intelligence. Those lab collaborators. So at least to serve the community, they go to market and monitor what's the price of energy product, petrol, kerosene, CNG, price of rice, basic foods. So we share so at any given time, if you are interested in knowing what is the price like, you can monitor the price before going to the market. So rather than you expecting somebody, government, to produce the data you need, most often in Nigeria, data is not seen as a public good. It's easier for them to build this massive university than for them to appropriate money to collect data about students that need to to benefit from this. Are you with me now? They will build railway, but they don't know how many. They will build borehole. No data about those who move. So, so data is not a public good in our official recording. Public goods are goods that you should be able to assess. Nobody can finish it. That's one property of public good. Everybody goes there, use it. The road you are trekking, nobody will finish the road. None of us will be. The airport, the railway, nobody will finish it because it's public good. You are supposed to go there, drive your car there, and then go back home. The same way it should be for data, official statistics, but there is no fund. If any survey is done by National Bureau of Statistics, they are donor driven, funded by IMF, World Bank, whatever. And because they are funded by them, the data gets to them first before we have access to the data. So they have already said so.
All right, Prof, thank you so much. We are very grateful for that. I think, let me, the second online person, please, you will permit us, because of our time, I will now hand over the mic to Professor Okoya to ask this question. Professor.
Sorry.
Let me
appreciate once again
for question.
This. In the course of your discussion, you showed to us the importance and the fact that machine learning is mathematical. And so I want to ask you, for the benefit of everybody seated here, you didn't speak much about it. You were just on the passing. Probably you can throw more light to encourage, especially the young ones, so that more people will be interested in what's happening. And the second one is closely related to it. Is that of the UI electricity survey you did. I observed also that when people go to make payments, sales person will say we should credit by account, and they will send it into you.
Oh,
I'm not saying generally. Okay. Now, it happens outside, but I don't know much about it. But I want you to speak to that, okay, because it's what operates. We're talking about people cutting corners. I mean, we spoke about that some 10 minutes ago. So this is also an area in which I'm sure the public would like to know more about. Thank you very much, sir.
Thank you, sir.
Before Prof, I ask
answer that question. Professor Mrs. too.
Okay, okay. It's better.
You know that it's not
It's
nice,
better.
but if the elder students are when the snail is going, the shell will follow. So let me allow them so that we ask. Okay.
Thank you very much. I know that Dr. Ola has another discipline apart from modeling, MC and drama. Prof, thank you for the beautiful presentation. Thank you for being a good teacher. Where I'm going is we have a project. We plan to use to apply machine learning to handle water treatments sometimes, and surface water now with specific, and we try to get data on surface water in Nigeria, real-time data now, because we needed to be able to predict if our activities, I'm talking from the environment point of view now, if we continue our usual activity the way we are doing in the next 4 years, in the next 5 years, what will happen to our surface waters, and by inference, our water treatment plants, will it affect the economy of how much they will spend to provide us with good water supply? But I couldn't get any data of such on our surface water in Nigeria as at 2023. So we said, okay, if that is the case, let us be the one to begin to collect the data on our surface water. So we decided to install sensors for the parameters that we need, like pH, TDS, temperature, and so on. We decided to install sensors on our surface water at Obafemi Awolowo University, and through the support of some NGOs and some research centers. So now, where I'm going is, after we have been able to archive data from 2020 for 2 years now. We have data every 3 minutes on Opari Reservoir at Obafemi Awolowo University. That makes us to have real-time data that we can then use for our projects. But archiving those data, we didn't have supercomputer to be able to store it by ourselves. So one of our collaborators, this research center, offer to archive them for us. We now have, we both have key to it. They cannot access it without us. We cannot access it without them. So it's 2 ways. Where I'm going now is, you said if they help us keep data before we see it, that they would have. that one makes my heart so. You want us to go about it? And what are the security, maybe cyber security, that we have to put in place?
Yes. Yeah. Maybe I should start from that question.
That's why they say women first.
So compromising data integrity is something that one can do unconsciously. Just the way we submit our data at every click. When we browse and say to accept the terms and conditions, I will say because you are desperate to use the app and so on. So, and then when you click up, you say I agree. In the condition, you won't read the lengthy condition. That's what I'm saying.
I'll go my cookies in them.
It's part of the strategy, because one, they need your data and you also need them. But when you know the data in what they are offering you won't want to submit your data. So they make it very difficult for you so that you will be in a hurry. They will to want to accept and move on because you are desperate. You know, most of the things we do when we are desperate, they are usually costly. They are usually costly. So with regard to this, I don't want you to feel or start feeling that they must have cheated or compromised the data. I wouldn't go that way. But I think the way forward is to acquire the needed storage or database that you can use to be able to be in full charge of your data. Now you can't accuse them of anything because you've not seen it being compromised anywhere, right? So, and it's not fair to start, since you both went into that understanding. I'm sure the understanding also allows you to take full ownership when you are ready. If that is there, then you can now start working towards having the needed storage database to preserve your data. The fact that you said it's you who will probably not be able to access without them. No, it's an assumption. That's why I said it's you. I will probably not. You will probably be the one, because you are not. It's just like your Gmail account or your this thing when you and it's like they don't have but your Google this thing. How many of you have received report from Google Map about your movement at the end of the
Yes, sir.
Maybe at the end of this month, this phone will come back and tell me, give me the location of this place that I slept here. But I didn't agree with it. It wasn't, I didn't request for the information. So they own it, and therefore what they own, they have, and they also issue you the access. You didn't give them the access. And then your university is the university is hosting it, right? It's residing with them. It's residing with them. They are the one taking custody. So the solution now is to work quickly to acquire the necessary infrastructure, yes, to keep your data. Yeah. And then you have full control. You will be in full charge. The other, my prof, the question regarding the payment system. In UI, I live on campus. So usually only one single bill will come to the university from the from the PhD and whatever. IBDC. Only one B will come to the university. But the university also has responsibility for academic areas. So they cannot be charging students in all of residence, in other laboratory and so on. Then you also have commercial areas on campus, and they have to pay for the bill. You also have residential areas. Actually, this one focuses on residential areas. So for commercial areas, churches and co-religious and so residential areas, what we do is when we want to buy units, we pay. Before we used to pay to the bank and take the teller to them and issue the unit equivalent to the amount we pay. And then you go with that unit and enter into your digital meter. That's how it's done. So, but if you have bought 50 units worth of units, 50 units worth of, power, electricity, for you, for those, anybody who wants to be fraudulent, you now tamper with the meter so that 50, if it used to last for 4 weeks, 3 months or so, now you can use it for 1 year. And it will not be reading. It will not be reading. So that's how some people perpetrate. In fact, some have been sacked because of that, even professors, because of that. So the payment system is supposed to be that if the commercial and so on, if they are paying, then the burden on the university will be less, because they are even almost they are consuming a very large chunk of the energy supply. The churches, the mosque, the commercial area, and so on like that. So that's why this study became very important, so that this machine learning approach to detect those residential areas where you suspect anomalous behavior. Then the machine learning is a field of study. Are you with me? One big family that put all these things together is the field of artificial intelligence. So in this field of artificial intelligence, you also have different families in that. So in that one family, you have statistics, you have mathematics, you have computer science, all engineering, and so on. They are all together. So because artificial intelligence is not, it's a multidisciplinary field. And so in this field again, you still have branches. You have the machine learning, you have data, big, neural kinds of deep learning, and so on like that. So it's a very wide area, but the machine learning is peculiar because one, you can use it mostly for predictive analytics. And we often distinguish between two types of pictures. You can have what we call supervised and unsupervised machine learning. So Even supervised machine learning is used when the target variable either or continuous. So if you are predicting, for instance, whether a student will graduate with first degree, second, you are predicting a class. So you will use the classification algorithm. There are techniques that will help you to do that. But if you are predicting the CGPE, for instance, which is continuous, right? Then there are other the machine learning that technique you are using. So there are different categories. You also have reinforcement and all of that. But in short, that's machine learning, mostly for predictive analytics. But like I said, you have to go beyond predictive. You could also have other areas of AI is data visualization, where you use different, you specialize in bringing insight through data visualization using infographics and different charts and so on to generate a report. I don't know if that answered it. Thank you very much.
Thank you. Please let's put our hands together. Right. We have come to the end of that wonderful presentation, and I think you will all agree with me that that was a beautiful presentation, and what all forms of appreciation. And in our own little way, as center, listening to this kind of talk should not go unappreciated. For that, I will invite our director, Professor E. Bakari, to actually make presentation of this award to our keynote speaker, who has done beautifully well, Professor E. Please, yes, sir, I request your presence again. Thank you, sir.
Thank you very much, Prof, for a very wonderful delivery. We appreciate it.
I said it.
You take a chance, you take your time, you spread the better you can come to. Let's go.
I have a question. Online participants.
Please, all the group, just join them, sir. Thank you so much. Yes. Now we will shortly be going for our
Sorry, afternoon. Afternoon. Anyone need help?
Okay, yes, a very good afternoon. Good afternoon. Can you hear me? Please, I'm on. Hello, good afternoon.
Good afternoon.
Yeah, good
Hello?
afternoon. I can hear you. My name is, yeah, hello.
Yes, hello.
Okay. Okay. I think the audio is seasoned. I could not get all.
Good evening to everybody. Emmanuel, are you here?
Walaikum assalam.
Are you here? Can you hear me?
If I come to a class, anything I ask you to do, please leave this place. Leave this place.
Okay.
It's that means where is the wood? Son ادفع.
Ils ont pris du temps.
مارجو كذا غير كتكون شاطر كل سكه با بيرو دولار دوك ثلاثه فرنسا فيهم في ليزين ماشي تزيرو
Oui, ça, oui, c'est bon.
ماشي بوسيبل ماشي يزيد معاهم بيرو دولار
Oui.
صافي
صافي.
معاهم
هادو فين يخرجوا كوالي تمسحوا. صافي سي بون.
صافي استاذ
صافي
لي
سي
زومبلو ديال ما تصيفطوهمش لهادوك الثلاثه سميتو
صافي سي بون.
حنا راه الامور حليناها مزيان
ما نخليهم.
صافي جيت نقول لك فين الشيء كيسميتو هذا ديك الساعه تزيرو بان خصها يخطر في شي وقت يكون معقول واحد 48 ساعه تقريبا
ماشي مشكل جيريو هذاك الكوارث.
ماشي تا هو يتفاداو
وي وي صافي سي بون. صافي. وي. لا يقول لي نيت لومبلوا دي طون. صافي صافي سي بون. Can you hear me please? Prof. Emmanuel, can you hear me? Prof. Emmanuel, can you hear me?
Good afternoon.
Oui, oui.
Yes. Please identify yourself. Please identify yourself. Yeah?
Good evening. Can you hear me? Good evening, everybody. Can you hear me, please?
Time is off, please.
We can hear you.
Time is off, please.
Can we start?
Please leave there. I'm having a meeting. Oh.
Can we start right now or not yet? Can you hear me, please? Yes, we can hear you. I think not many people are responding. We can hear you. I don't know if you can start or not yet. Right? Can I start? Professor Emmanuel, can you hear me?
I think we can hear you now. You can proceed. I don't know for the others.
I'm here. We can hear you. Go on.
We
can hear you, sir.
Can we start? Professor Emmanuel. I don't know, there is some problems about network or there are some issues about network. I don't know. There are some issues about network. Can you hear me?
You are welcome back, everyone. Okay, Professor Khalid.
Yeah.
Are you there?
Yes, I am here. Yes.
Okay, good. We are sorry we had some technical challenge to which we have to fix. That's why we have not been able to come online. Thank you so much. So, please, everyone, we are going to be having the very last speaker of this conference. And of course, one of the things that you would want to expect is that if since the beginning of the conference up to now, we are rounding off with this last one, you want to give all your attention because bottom pot, you know the way it's tastes. Bottom pot is very sweet. So I believe that it's going to be a sweet presentation, a great one indeed by Professor Zimri Khalid. So I'm going to invite Ms. Blessing to give the citation of Professor Khalid. Please join me to welcome Ms. Blessing to do that. Please appreciate Ms. Blessing.
Citation of Professor Ezimbe Khalid, Laboratory of Mathematics and Population Dynamics at the Ayad University, Faculty of Sciences, St. Maria, Department of Mathematics, Marrakesh. Contributions to the development of new methods for solving partial functional differential equation. Professor Ezimbe is a Moroccan scholar whose research focuses on differential equations and dynamical systems. He works at the Laboratory of Mathematics and Population Dynamics of the Faculty of Sciences, St. Maria, of the Qadi Ayad University, Marrakech, Morocco. He earned his PhD in partial functional differential equations in 1997 at Qadi Ayad University. His current areas of interest cover differential equations, dynamical systems, evolution equations, and partial fractional differential equations. His research interests are evolution equations, operatory theory, partial fractional differential equations, dynamical systems, and integral differential equations. He serves as an editor-in-chief and an associate editor for several mathematical journals. He has been a visiting professor at numerous universities in African, Asian, European, and North American universities. He's a member of African Academy of Sciences since 2009. Professor Kari has had several PhD students in many countries, including Morocco, Senegal, Chad, China, Nigeria, Cameroon, Burkina Faso, Tunisia, and Ghana. Professor Kari has supervised 30 PhD students from Africa. These are outstanding achievements for a mathematician working and living in Africa. He was a member of several doctoral dissertation committees in Africa. His works inspired many researchers and influenced many publications worldwide. Professor Ezembe is fluent in French and English and has co-authored several publications. He is very flexible and adapts easily to different work environments. Professor Kari has over 270 papers indexed and 3,901 citations. His page index moved recently to 36 with Google Scholar. Join me in welcoming our own distinguished Professor Ezembe Kari. Welcome, sir.
Okay, thank you very much for this nice introduction. So can you hear me?
Yeah, we can
Can
hear
you
you, but if you
Yes.
can make it
First of
louder,
all,
would appreciate.
okay, donc I would like to thank Professor Emmanuel for this kind of invitation. And then I am pleased to talk to you to one of my work that I have done recently. So the aim of this work is not technical things. I want just you to take messages from that talk. This is very important because technical things, if we need them, then we can find them immediately. So I start to share with you my talk, and I don't know if you can see my slide.
Yes, we can.
Okay. And this is about periodic solution and then attractiveness for some partial functional differential equation with lack of compactness. And then I remember I sent another title to Prof. Emmanuel. This is about wake topology, and this is included in the talk. So we use wake topology instead of strong topology to get some new results and then to apply them for several models when strong topology cannot be applied. So this talk is based especially in two papers that you see here. One is in applicable analysis in 2020, and this is the next proceeding of the American Mathematical Society. And the talk is based on the two papers. So let me just start from the beginning, and this is the talk. And you see here section 2. This is very important. This is the newty of that paper. New fixed point theorem for affine maps in locally convex space. This is more general than wake topology, because if you have wake topology, then of course the vector space provided with wake topology becomes locally convex spaces. We know this very well. And this new fixed point is just for particular maps. This is what we call affine map. And I will explain what does mean this. And then behind of this, we have a lot of application, especially in differential equation, and then dynamical systems. For example, if we need to solve the problem of periodic solution for non-homogeneous linear equation, like evolution equation or partial functional differential equation, etc., etc. I will give you some application of this new theorems. As I said, this is not, the aim is not technical things. I don't want you to take care of technical things. I want just to get messages, how to build this work, how to get our result, and what are the motivation behind of this result. So affine map. So let me just start by this Poincaré approach. Poincaré approach is the first mathematician who really studied the problem of periodic solution for nonlinear differential equation. So if you just let me remind you the idea of Poincaré map, and this is what we are going to use for affine map in Banach space. So Poincaré considered the following nonlinear differential equation, and then he assumed that f is periodic with respect to t, which means that the input function is periodic, and then he asked the following problem: do we have a periodic solution? And then you are going to see that the idea of Poincaré is very simple, but behind it we have a lot of application, and right now a lot of researchers still using this technique. So we suppose that our problem one, this nonlinear differential equation, is well posed in Hadamard sense, means that you have global existence, at least for T to be positive, you have uniqueness, and then we have dependence, continuous dependence with respect to initial data. For example, if we assume that f is globally Lipschitz with respect to the second argument, and then of course we can prove, or you have seen it, that equation one is well posed in Hadamard sense. But in most of cases, we don't have global existence, we have local existence, and then even that, the problem can be shown to be well posed in Hadamard sense. Can you hear me?
Yes, sir. Yes, sir.
Okay. And let me just to share with you the idea of Poincaré. This is the aim of this talk. I need you to get messages. Because for young researchers, this is the message that I want to tell them. If they want to start research, they have to go back to the old papers and then read them very well. And there you can find the basic theory, the idea that all the researchers have developed. So let us go back to Poincaré approach. And then Poincaré said, if I want to talk or to look for periodic solution, you have just to consider what we call the Poincaré map. And then the Poincaré map is map that is defined from Rn to Rn, and P of U0, this is the initial data, this is the value of U at omega. This is the period U0, and because we assume that the problem is well posed in Hadamard sense, that means P is well defined, is continuous, everything works. And then here, listen, this is the idea that Poincaré has. If P of U0 is if P of U naught is U naught, means that U naught is a fixed point of P, then immediately you can prove that the solution starting from U naught is omega periodic. So you see that the idea is very simple. So to log for periodic solution for equation one, it becomes to log for fixed point problem for the Poincaré map. And then now, if you need to log for periodic solution, you have just to log for fixed point of that map. And behind this, we have a lot of theorems from fixed point theory. Then we can apply them. And then we have a lot of works, lot of books, lot of papers, just where the author used the Poincaré approach. And this is some picture that I want to share with you. The first one, this is the Poincaré map. Second one, it shows you when P, when you note is fixed point. And you see that here you have periodic solution. And then why do we need to log for periodic solution? Because it can be limit cycle limit for equation one. Means then you can have global attractor that is given by this periodic solution. So after that, there is another idea of research to see or to prove if the periodic solution defines global attractor. So our talk, as I said, this is the Poincaré approach, and this is what I am going to use for affine map. This is the approach, and this it was discovered, I think, in 1925 or something like that by Poincaré. And this is what I am going to use. So affine map, you know this from elementary school or high school. Affine map in R, this f of x to be ax plus b. You know this very well. And then from high school or elementary school, f has a fixed point if and only if a is not 1. You know this very well. So what happened to this condition when we work in high dimension, especially when R is substituted by Banach space, and then its dimension is plus infinity. This is what we can find when we are dealing with evolution equation or partial functional differential equation or partial differential equation only, without functional differential equation. So this is, you know this very well, and this is some pictures. And if you need f to have fixed point, then you have just to assume that E is not 1. So we are going to see what does mean this. So now, what is affine map? So if you see here, affine map in R is given by this A of x plus vector does not depend on x, because the argument here is x. And what is AX? Is linear map, not linear map. This is the only linear map that you can find in R. If you take map from R to R and you say that map is linear, then it in general context is what? Is linear map applied to X plus vector does not depend on X. This is the meaning of that. Affine map in high dimension, maybe in vector space, when its dimension is plus infinity, it can be this f of x is b of x plus b. This is affine map. When b, it can be linear map or matrix. Linear map, of course, bounded. This is L of x. This is a space of bounded linear map, or it can be matrix, or it can be linear map from Rn to Rn. So before to start to look for periodic solution for some kind of evolution equation or some kind of dynamical system, the problem first is to find a fixed point for that map. So when you are in R, in scalar case, we know what this means. This, you have just to assume that E is not 1, and then you can find fixed point. You can compute it very well. So the problem here is not easy because we work in high dimension. It can be Rn or it can be X. Dimension of X is plus infinity, and then we have a lot of theorem to use, taken from spectral theory or from linear functional analysis. We are going to see this in the next. So let us start by the first theorem that was obtained by two big mathematicians, Shaw and Hill in 1974, and this for linear, for affine map. And let me just to show you the theorem that they obtained. because they have this problem. And this problem, u prime of t to be L u sub t plus f of t. This is what we call functional differential equation. And behind the form 2, we have a lot of models coming from population dynamic, biology, ecology, so physics, chemistry, a lot of. This is what we call daily differential equation or functional differential equation, because the initial, this is another talk. Donc I am not going just to take care of this. Just I want you to take message, and this is another theory to model phenomena in our life. Because the initial data is not vector, this is function that is taken from C. This is a space of continuous function from -R0 to Rn. And this is the problem solved by Shaw and Hill in 1974. And this is the input function. And then you want to prove periodic solution using the Poincaré map. This is the same idea that was discovered by Poincaré. So they consider the following Poincaré map from that space, because this is the phase space of equation 2. And you see this is just P of phi, u sub omega phi. And what is u of t? This is what we call the historic function. And the historic function is defined by this. U sub t is map taken from C. You apply, if you apply it to theta, this is u t plus theta. And then the philosophy behind this, because if you need to model any phenomena, you have to consider its past. And this is very natural to assume, and this is very worthy to use it when we try to model. And then behind this, we have a lot of papers, a lot of work, a lot of books. So Shaw and Hill used the Poincaré map. And then this is the Poincaré map. And then they observed that this Poincaré map is a fine map, because the problem here is non-homogeneous, because F does not depend on U. This is what we call non-homogeneous linear problem. And then this is u omega applied to phi, because the variable here, the argument is the function phi. And then this is u sub omega 0f does not depend on phi. You see it here. And then, of course, because u omega is what exactly is the solution without f. Is it clear? And of course, it is linear with respect to phi. And it is linear with respect to phi. And then the second vector, this vector does not depend on phi. And then, of course, this is a phi map. This is an example, the first example of a phi map. And then the idea of course, because this problem is well posed in Hadamard sense, we have global existence, we have uniqueness, we have everything, because L is bounded linear operator from C to Rn, and then everything works. And then we have uniqueness, we have global existence, and then we have continuous dependence with respect to initial data. So this is the problem that they want to solve. And then the problem now is to find fixed point of P. Then they forget, this is the message I want to say for young researchers. They forget the problem of periodic solution, and then they are front of another new problem. And then what is this new problem? Fixed point for affine map. Let A be a Banach space, K be an affine map. That's mean K of X to be K not X plus Z. K is bounded linear operator. Does K have fixed point? This is another problem. And this problem is linked to fixed point theory. And this is what they have discovered. If we assume that the range of A minus K naught is closed, here I is the identity map, and then at least you can find X naught such that K power n X naught is bounded. As the sequences is bounded, then T has a fixed point. And then if you see the proof of this theorem is very easy. It's very easy, is based on Banach, on Han-Banach theorem. And then this is the first theorem that was discovered by Cho and Hill in 1974. And this is the theorem. Now, they applied this theorem to where? To that equation, to this problem, because the Poincare map is fine. And then U of omega is compact. This is the dynamic of this equation. Because U omega, we can prove that if omega is bigger than R, and then here R is the delay, then U omega is compact. And from compact operator theory, you know that you have this condition immediately. Then I minus U omega is closed. And then if you have at least bounded solution over R plus, then this, it gives you condition double I, because you take X naught to be exactly the initial data of that bounded solution, and then you have double I, and then you can apply immediately this theorem, and then the Poincare map has a fixed point. This is what Cho and Hill have done. So here they use strong topology. Can you see it here? Everything here, we use strong topology. And then for us, we are going to relax this theorem. We try to find some theorem like this, but without using strong topology. We use just weak topology. And this is the first aim of this talk. And then after that, we apply our new theorem to find periodic solution for non-homogeneous. This is our theorem. So you take A capital F. This is not strong topology, biotopological vector space. And we assume that A capital F is locally convex. You know what this means. F, the origin, has a basis of convex neighborhood. Donc ça, c'est classical definition. And then if you substitute F by weak topology, then you have this. No problem. So this is our theorem. And you see, is more general than using a weak topology. Just we work with locally convex space. So you take capital AF to be locally convex space, and then F is continuous, you see here, and then of course K is Offenbach. And then here we use continuity, but not using strong topology, using topology of F. And this is more general than weak topology. So if you assume that X naught such that the closed convex or X is F compact, means with this topology, then K has at least one fixed point in capital A. So if you see this theorem at the beginning, you can say it is an abstract result, but actually not, because behind of this theorem, we have a lot of application. And then, of course, I will show you some of them. Can you hear me?
Yes, sir. Go ahead. Yes. Go ahead.
Can you hear me? Okay, thank you. So, and then, as I said, if you substitute F by weak topology, then you get this. And then if you take weak topology, this condition is equivalent to what? Just to say that this is bounded. Do you understand? If you substitute capital F by the weak topology, then this condition becomes what? K power n X naught is bounded. Because if you work in a reflexive Banach space, for example, if it is bounded, then it is weak compact. So this is another theorem also for Offenbach and locally convex space. F compact, then you have at least one fixed point in capital A. This is compact. Yeah, this is the theorem. So if you are in Banach space, then it becomes Banach space such that, yeah. So this is another theorem, just corollary of the first one. If you are in Banach space, this is often mapped, and you assume that this is relatively weakly compact, then K has at least one fixed point. Mean we use here weak topology. So this is some classical, some corollary that we obtained of this. If you work, of course, in reflexive Banach space, then you know that if K power n x naught is bounded, then of course it is weakly compact. Then of course K has a fixed point. So if you compare our theorem with Shaw and Hill that was obtained in 1974, our result of course is better. And then it has, of course, a lot of application. Then we are going to say them. When we cannot use strong topology, then at least we can use weak topology. This is exactly yes. Our theorem obtained by Hill and Shaw becomes, of course, particular case of our theorem. So this is some message that I want to share with you. To find theorems is very nice, but the problem is to motivate them. And then the best way to motivate them is to find application. Application, when classical theorem cannot be used, then you can justify your theorem, and then it will be very good for what you have obtained. So let us start by evolution equation. This is some kind of non-homogeneous linear equation. A, this is the generator of C0 sum A group. And then we assume that the input function is omega periodic. And then you can see that the Poincare map is affine. Just we use this variation of constant formula. And then this is some example. Evolution equation. And then behind this, we have partial differential equation as an example. So the Poincare map is affine. Then if you try to apply our result, then you can find a fixed point of P. And then that fixed point is the initial data for a periodic solution. So let us go back to the first example that I give you about affine map in R in scalar case. That condition E is not one. What does it mean in high dimension? And then we need to do a lot of spectral theory. And then let me just to start with this definition. This is what we call the essential spectrum for B. And then the essential spectrum of B is defined by this. This is lambda in the spectrum, such that at least one of the following condition is satisfied, the range or 2 or 3. And this part is very important in the spectrum. And then if you are dealing with this part, you need to control it very well, because otherwise you cannot do anything after that. And then we defined what we call essential spectrum is defined by this. And then this is the essential norm. And then essential norm is exactly, this is the same norm of using strong topology, but here we use measure of no compactness. So, and this is the condition that we have seen in R. What does mean this in high dimension? Means that you have to compute, you have to do spectral theory, you have to compute the essential radius of P by this formula, and then you have to find this condition. This is the meaning of this condition in scalar case. So if you have this condition, it means that one is not in the essential spectrum of that operator. And now, if you go back to the definition of the essential spectrum, means the range is closed. If the range is closed, then you can apply the previous theorem that we have seen by Hill and Shaw, because you have this condition. Don't forget, this condition is very important on that theorem. And then this is what you need. And behind this condition, believe me, a lot of work. Spectral theory, and the essential spectrum, and then essential radius. And then you have to check that you have this condition, and then you can apply Hill and Shaw theorem, and then of course you can have at least one omega periodic solution. So let us see this corollary. It says what? If we suppose that this is compact, of course, you know why do we need this condition? Because we look for I minus T omega to be closed. That's why, because if this is compact, then the range of I minus T of omega is compact, and then of course you can apply those fixed point theorem for a affine map. But my problem is here. When you model, we don't have this condition. So if you have this condition, means that you are lucky. But most of models that we study, we don't have this condition, because we work in dynamical systems that are well posed in high dimension, and then the phase space is dimension can be plus infinity, and then our theorem will solve this case when T omega is not necessarily compact. Then what happened? And then this is an open problem that was also posed by Hill, I think in 1975 or 7. He wanted to extend his theorem for functional differential equation, not in Rn, but in Banach space. And then at this time, he couldn't solve the problem. So what we are going to solve, some of those problems. So look at, if we apply our theorem, if there exists X naught such that this is bounded, this is nothing, we can have it. This is relatively compact, means that the closure is compact, then equation has an omega periodic solution. No, this is no problem. And the most, yes, if you suppose that there exists X naught such that this gamma plus X naught is relatively weakly compact. For example, if it is bounded and you work in reflexive space, then you have this for free. Then you can have equation has an omega periodic Mite solution without assuming that T of omega is compact. Yes, you see here, if you are in reflexive Banach space, then this is bounded, then immediately you have an omega periodic solution. Yes, this is some corollary of this. So we go we go here for another extension, and then there is no need to assume that the semigroup generated by A is compact, but only the resultant operator is weakly compact. But if you work in reflexive Banach space, then you have this condition, no problem. Weakly compact means it takes bounded state to say that is relatively weakly compact. And then this is equivalence. You have equivalence between existence of bounded uniformly continuous solution over R plus, and then existence of an omega periodic solution. Uniqueness here, you can prove that the periodic solution can be global attractor. If you assume that the C0 semigroup is stable, then we can prove, and then this it has been proved in that paper published in Proceedings of the American Mathematical Society. This is some example, and then I can close my talk. This is some example taken from population dynamic, and you can see the example here. This is a model that is given by partial differential equation. I'm not going to give you the details about the model, but it has a lot of application in population dynamic. This is partial differential equation, and then we assume some technical assumption. We select the operator domain of A is exactly that linear par you see here, and this is the input function. And then with this transformation, you can see that the model 3 is equivalent to 4. We work where here? Our phase space is in that space, that is a Hilbert space. Of course, it is reflexive. Then if you have bounded solution over R plus, then we apply our theorems, then you can find an omega periodic solution. This is another application for functional differential equation. This is in Banach space, not in Rn. Show and Heal studied equation A in Rn. And then in Rn, you can apply Ascoli-Arzela theorem to find compactness. Here, we don't have compactness. And then we apply our theorem. So if we assume that equation 1 has at least bounded solution over R plus, then you have an omega periodic solution. This is another example also for functional differential equation. And then here we construct the bounded solution over R plus. This is some example of partial functional differential equation. So on, we have a lot of application. I think I am going to stop here. If you need this work, I can send it to you, no problem. Transport equation also with delay. We have a lot of application with delay. The idea is the same. And then I want to share with you some references related to this work. And then thank you very much for your attention. And then if you have any question or comments, I am here to respond to you. Can you hear me, Emmanuel, Prof. Emmanuel?
Yes, we can hear you, sir. Thank you, sir, for that presentation. And I think that some of our friends here who are of the functional and pure mathematics background, you would really see that a lot of rigorous work there is done around periodic solution, adjunctiveness for some partial functional differential equation. It's a lack of compactness that Professor Ezimbi has looked at, and he has consistently demonstrated the existence of omega periodic solution, which he showed throughout that study, and then the applications to different areas that we have. So in also even in age structured population dynamics and the rest of those things. I think some of you have come across the issue of Poincare approach here, so you want to determine if there is omega seasonality, omega periodic solution, and all of that. Now I think it's a good time to now engage you. This is a bit pure. I mean, do I say a bit? It's completely pure. So dynamical system, pure dynamical system. So I want to believe that we enjoyed it, and then let me allow us to ask questions. Questions from the audience. Yes, I was expecting that. So I have one. I'll also give. Okay, so Prof also wants to ask questions. The online participants, you have questions, please signify as well so that I can count you on time before we go on to the next thing to do. Okay, so I will start from this place.
Hello, sir.
Hello,
Are you
good
there, sir?
evening. Yes, I'm hearing you. Good evening.
Okay. Thank you for a very strong presentation that you have just given. For quite some years now, I've been looking forward to see something like this. That real application of pure mathematics to some real life situations. But sir, I have a few questions. Number one, did you test for if these spaces you mentioned, because when you state a theorem, then sometimes you write some expressions, some equations, and you say it is a Banach space. It is particular space. Sir, did you test if these ones satisfy these spaces, sir?
Which one? Sorry, the last one. Yes, the last. Yes. What you said last words.
As I said, did you test if these expression, if they satisfy these spaces you mentioned them to be?
Which one? Which one? Let me share with you the slides. Which one? You are talking about what space? No, let us stay for question one. So let us go back to the first of this talk, and then let me show you. Yes, which one? Go ahead. Yes, which one? Yes. Yeah, go ahead. Yeah.
Equation 2. Equation 2. It was labeled 2.
Question 2, yes. Go ahead for question 2.
Yes, it was labeled on the right hand side 2.
I cannot hear you.
Have you got what I said, sir?
So what can you go for question number 2?
Question number 2. You mentioned something on the relative Banach space. Relative Banach space. Please, I would like you to explain on relative Banach space. What do you mean by relative Banach space?
No, I didn't see no. I didn't see relative Banach space. I see the relative compact set. Relative compact set. You take the closure using strong or weak topology or F topology. Relatively compact set.
Okay.
Mean the closure. You take the closure of the set, and then the closure is compact using strong or weak or F topology.
Okay. Okay.
Is it clear to you? Is it clear to you?
Yes, it's clear. It's clear to me. It's clear.
Okay. About number one, I didn't hear you very well about number 1.
The first question, you have not gotten to the equation 2. There's an equation labeled 2 on the right hand side.
Question, please. Question.
So we go for slides.
In the course of the presentation, there was an equation.
Which one?
Equation 2.
Which one? Number. What is the number of the equation?
Yes. This one show an L 1974.
Yes.
Equation number 2.
Yes, you are asking about. You are asking about equation 2.
Yes.
So what is the question now?
You were talking about this one has a fixed point. If and only if equation 2 has omega periodic solution.
Yeah, correct.
Sir.
Because you want
to prove that, sir?
So listen. I said in my talk, this is particular case of differential equation. This is not classical differential equation. This is what we call functional differential equation. So from the basic theory of this kind of equation, this equation is well posed in Hadamard sense. Means we have uniqueness, we have global existence, and then we have continuous dependence. So the Poincaré map is here, is defined, but the phase space is C from minus R0 to Rn. And then since equation 2 is well posed, if you can find fixed point of P, then you can have an omega periodic solution because phi, P of phi is phi. That phi is the initial data for that periodic solution that we are looking for. Is it clear?
Is
it clear to you, Prof? Okay, good.
It's clear to me,
Okay, thank you.
Please, can you make the slide available?
Slide? Which slide?
Yes.
Which slide?
Yes, sir.
This slide.
If you would make it available, but I can have more insight into what you are doing, sir.
If I can make it what?
If you can make it available for me after this presentation.
Can we get the slide?
Can we get the slide?
Okay. No problem. I will do it.
Okay. All right, thank you. Thank you very much. That's all.
And if there's any,
You don't have 10 hours for this.
I want to ask now, how does your periodic solution, how does it relate to almost automorphic? Almost automorphic. Also, almost automorphic. Then number 2 is that what is the place of the flow theory on some of these periodic solutions apart from the Poincare approach? Thank you.
Okay. So can you listen? Can you hear me?
Yes, clearly, sir.
Okay. You are asking about automorphic solution. All right?
Almost automorphic solution.
Yes, almost automorphic solution is more general than almost periodic solution. Is it clear? And then almost periodic solution is more general than periodic solution. For almost periodic solution or almost automorphic solution, we cannot use Poincare map. It doesn't make sense. We use just definition of automorphic function or almost automorphic function or almost periodic solution. This approach cannot be used even for almost automorphic solution or almost periodic solution. Is it clear?
Yes.
Just we use definition because we have a lot of works devoted to this kind of solution, and then we cannot use Poincare map. We use just definition and then properties of almost automorphic functions.
So the next question is about the Foucault theory, the place of Foucault theory in this omega periodic solution. Is there any link? Where does Foucault theory come in?
Can you please repeat, because problem of network?
The question is, where does Foucault theory come in here regarding omega periodic solution? Where is the link with Foucault theory?
Last word, which theory?
Where is the link of this omega periodic solution with the Foucault theorem? The Foucault.
Wait, that theorem, it says what?
Yeah, that's where does it come in? Where is the link between this and Foucault theory?
Yeah, what this theorem that you are saying, what does it mean? Last theorem.
So the issue is that in dynamic cast systems that have omega periodic solution, sometimes it's difficult to look at, and then we want to go through the route of Foucault theory in order to prove in order for us to go around that period dynamical system that has omega periodic solution. So we are saying what you are doing now, where is the place of Foucault theory? Where does Foucault come in?
Yes, I understand. You are talking about Foucault theory. Foucault theory.
All right.
Yes, Foucault theory, this is an interesting theory for non-autonomous dynamical systems, and especially for periodic dynamical systems. And then for Foucault theory, we assume that we have a periodic solution. Do you understand? We have. This is not, for me, I don't assume that I have. I prove that I have solution. So for Foucault theory, you suppose that your ordinary differential equation or something else has a periodic solution, and then we compute what we call the linearization principle around that periodic solution. You understand? And then we try to prove if that solution, that periodic solution, is globally attractive or not. Do you understand?
Yeah.
Do you understand? So for flow theory, yes, you assume that you have periodic solution. Then we go for what you call linearization principle around, and then we use flow theory to check a lot of things to prove that periodic solution is attractive.
Okay, thank you, sir. Thank you so much
no
for
problem.
this presentation. I think for some of us who may really love to go in this pure aspect of mathematics, you want to see how, check the concept of attraction, around periodic solution. You may want to consult this kind of mathematics, and it's a beautiful one. It helps you to engage your thinking so much. So thank you so much. And then I will now hand over the line to our dear Professor Emmanuel Abibakari to appreciate our presenter.
Thank you. Thank you very much.
Thank you very much. Can we see your face, Professor Khalil? Yeah, they want to see your face, not the slide.
Yes. Okay, no problem. Let me just use my camera. Can you see me now? Can you see me now?
Thank you very much. Yes, I can see you.
Okay.
So, everyone saying thank you for your talk. We appreciate you. It's very interesting work because, especially work in the space of periodic solutions in epidemiology models. So, when we put in some periodic functions on mosquito population, or birth rates, or the transmission rates, we put some periodic solution like sinusoidal solution and all that. So these are some of the things we also, and then some of the theories you have propounded, they are also useful in epidemiological models of malaria and cholera, some of these diseases, and to look at, especially when we are proving, when we are doing when we are trying to do the theory of a periodic solution given a particular mathematical model that is non-autonomous systems. Thank you very much for that.
Thank you. Thank you very much.
Can we give him a round of applause again?
You said?
So I said people should clap for you again. Clap. They are clapping. You can see the online clap and the physical clap. Let's stand up and clap.
Okay, thank you very much. Okay, thank you very much. Thank you.
Yeah, great talk. Thank you.
Okay, thank you very much. Thank you very much. Thank you.
Have a nice time. Thank you. Bye.
And
thank you.
Don't forget,
have a nice day.
Please don't forget to send the slide. I appreciate if you can send the slide. Yeah, thank you.
Okay.
All right.
Okay, no problem. Okay, no
thank
problem.
you.
Thank you.
Thank you so much.
Thank you.
So we'll now go for the last presentation. The online presenters, the few of them that remains, we'll take them and then, we are waiting for the launch. The launch is on its way. So when it comes, I believe by that time we'll have finished whatever we are doing, so that we just end the program from there. All right. So so we are going to be having the presentation from Dr. Jackson, who was trying to present in the morning on auxiliary Lyapunov functions. And please, can you stay on the first page, students? And uniform practical stability for non-linear inclusive capital fraction and their derivative. Dr. Justin, can you confirm that you are online? Are you there? Please, can you respond if you are there?
Yes.
So Jackson,
I'm online.
now you have the floor. You have 10 minutes to go. Please, you can start now. Thank you.
Okay. My name is Jackson Ante, and I'm presenting on a topic On auxiliary Lyapunov functions are uniform practical stability for nonlinear Caputo fractional order derivatives. So we have about 5 in the paper, and as the corresponding author or lead presenter, let me go straight to the abstract. Now, this paper investigates the uniform practical stability of the trivial solution in nonlinear impulsive Caputo fractional differential equations with fixed impulse moment. An auxiliary Lyapunov functions which serves or which is an analog of vector Lyapunov function is employed and is generalized through a class of piecewise continuous Lyapunov functions. So we adopt the comparison techniques to establish sufficient conditions for uniform practical stability of impulsive Caputo fractional order systems, and then we validate the results with an illustrative example. Hello, Doc, please. I think I can get to the next slide. Introduction. Fractional calculus extends classical calculus to arbitrary orders, enabling more accurate modeling of memory-dependent dynamical systems. Its applications spans physics, engineering, and control theory. The stability analysis of fractional systems, particularly practical stability, was introduced by Lassalle and Lefschetz in 1961. About then since then, research interest actually sparked off. Now, practical stability actually comes into relevance when the need to establish asymptotic stability of solution becomes very restrictive and difficult. So there becomes a need to go into practical stability, and then further works by Martin Hugh and Kong Wu were established in 1983 and 2012 accordingly. Next slide, please. The current research gap that our work seeks to cover is one, the impulsive differential equations model systems with abrupt state changes at discrete moments, which are essential for real-world processes, as noted by Bainov and Simeonov in 1989. The combination of these effects with fractional derivatives introduces complexity in stability analysis. Now, by extending Lyapunov sort to fractional order systems, there is the need for a careful definition of fractional derivatives, and a challenge addressed by Agarwal in 2015. Now, what Agarwal did in 2015 was actually to use a scalar Lyapunov function to establish stability of solutions. So what our work seeks to establish was to extend that work from the use of scalar Lyapunov function to vector Lyapunov function. Now, the limitation in the scalar Lyapunov function is that we try to use the Lyapunov function in sum, as it were, to establish, to analyze the steady states of the solution. But in vector Lyapunov function, we split the solution state into components. And then together with the Lyapunov function, so that each of the components of the Lyapunov function can safely tackle each state of the trivial solution. Thus, whatever restriction that must have been occasioned by the scalar Lyapunov function could be safely handled by splitting the Lyapunov function into components. So we actually extended the work that was established by Agarwal in 2015, and then we redefined its Dini derivative to capture the vector Lyapunov function. Studies on practical stability by such systems using vector Lyapunov functions remain scarce, which actually motivated this research. All right, next slide, sir. So problem for formulation is, first of all, we formulated a system of impulsive capital fractional derivative, which is we defined by equation 3.3, and together with the components of solution state, which are elements of vector Rn. F is a continuous mapping of a vector function of a vector variable. And Tk is in Rn, satisfying the following assumptions of I, and I. Please, let's get to the next slide because I want to say something about the comparison system. Okay, methodology overview. We employ a piecewise continuous vector Lyapunov function, V of Tx, and decomposed it into components corresponding to system states. This approach simplifies analysis compared to a single scalar Lyapunov function, which was actually the approach that was used by Agarwal in 2015. The fractional derivative of the vector Lyapunov function is defined in the capital sense, and a comparison system is constructed to derive stability criteria using monotonic functions and impulse conditions. So what we actually do, we adopt the Caputo because Caputo is a bit easier to work with. There is also another aspect of fractional derivative, which is the Riemann-Liouville, but the Caputo is easier to work with because the properties of the Caputo fractional derivative is similar to that of the classical derivative. So we adopt the Caputo derivative.
Dr. Jackson, you have 5 minutes.
Comparison system to construct.
Hello, Dr.
Now,
Jackson.
the comparison system, which is actually the backbone of the next slide.
Hello, Dr.
Slide,
Jackson.
please,
Hello, Dr. Jackson. Can you hear me?
Yes, sir.
You have 5 minutes more.
All right, sir. Next slide, sir. So comparison result, in what we do in comparison result is, my system 3.3 is a complex system. So my comparison results seems to be a simpler system that kind of mimics equation 3.3 to the effect that I can be able to use the comparison system to establish stability results for, that a stability result that gives me the conclusion that if the stability holds for the comparison system, automatically it will hold for the main system. So my main system was system 3.3, and my comparison result is actually by the theorem 4.1, which is stated here. So I use the conditions of theorem 4.1 to establish the stability of system 3.3. So my comparison result seems to be a simpler version of system 3.3, so that the stability analysis of system of the comparison theorem or comparison result, is used as a basis for the conclusion of the stability of the system 3.3. So that's what the comparison result here is all about. All right, sir, next slide, sir. So my main result is actually system theorem 5.1, where the condition I, and I holds. In condition I, the left side of the inequality is actually the stability, while the right-hand side is the decreasant property. So I am merging the two results together. The decreasant property is actually the uniform stability, while the right side, the stability of the system. So we say that then the system, the uniform practical stability of the trivial solution of the comparison system of 3.5 implies the uniform practical stability of the trivial solution of 3.3. I've said that earlier. Next slide, sir. So my illustrative example is captured in the following application. So what I did was I formulated a system of impulsive fractional differential equation, which I call 6.1. So what I did was to split the Lyapunov function into components and then split the states, that's the trivial solution, into components, and then use the component of the Lyapunov function to examine the solution of the trivial solution. And the next slide, sir. Hello, sir. Hello. And then I resolve those components and arrive at system 6.6. It's actually a very rigorous estimation. And the summary is that the matrix A, it's a Metzler matrix. The Metzler matrix in the sense that if we resolve the matrix A using the eigenvalues of the matrix A will give us negative real parts. The two values of the eigenvalues will be negative for the two. So once the eigenvalues are both negative, then we infer that the system is uniformly stable, or asymptotically stable, as the case may be. But in this case, my target was to establish the uniform practical stability. So my system is actually uniformly practically stable in the sense of Lyapunov, since my eigenvalues will both be negative. My conclusion. In this paper, we investigate the uniform practical stability of nonlinear impulsive Caputo fractional differential equations with fixed impulse moment. The analysis is carried out using an auxiliary Lyapunov function. The auxiliary Lyapunov function here is actually an analog of vector Lyapunov function, and further generalized through a class of piecewise continuous Lyapunov function. A class of piecewise continuous function is a function that is one, that is continuous, two, and satisfies Lipschitz conditions. So as we generalize it in the context of piecewise continuity, we are using it because as we adopted impulse, there are abrupt changes. So we have to define our Lyapunov function in the sense that captures piecewise continuity. That's why we need to generalize our vector Lyapunov function into a class of piecewise continuous functions. So by decomposing the vector Lyapunov function into several components corresponding to the individual state variables, each component is being associated with a specific state variable rather than combining all states into a single Lyapunov function, as in the case of the scalar Lyapunov function. So this decomposition simplifies the derivation of the desired practical stability result and leads to less restrictive stability conditions. In conjunction with comparison principles, sufficient conditions ensuring the uniform practical stability of the impulsive Caputo fraction are established, and an illustrative example is being provided to demonstrate the validity of the theoretical findings. Thank you so much, Profs, for listening. Hello? Hello?
Go ahead, we are hearing you. Go ahead.
All right, so I said we now to ask question.
I'm struggling to hear you, Doctor. I'm struggling to hear you.
To give people opportunity to ask questions.
Okay.
All right, so question? Okay, yes. Let's have this question. All right, Dr. Jackson, thank you for the presentation. Can you hear me?
I'm hearing faintly.
Okay, can you, where do we go to now? Can you hear me now clearly?
All right, sir, go ahead.
All right, so I want to ask, for instance, equation 6.1, where you applied your method, were you able to, how did you validate some of the results that you obtained? How did you validate it, especially for equation 6.1 that you presented?
Okay, the first two lines of equation 6.1 is actually Caputo derivatives, functions related to the Caputo derivatives, where the right hand side is actually f of t comma r. I'm using it in the context of non-autonomous systems. And then the next two equations in 6.1 is actually about impulse and trivial initial conditions. So what I did was that I picked the first Lyapunov function because I am splitting the Lyapunov function into components. So as I add the first two lines of equation 6.1, I picked the first Lyapunov function and resolve the first line of equation 6.1, and then I pick the second part of that, and then I resolve that also. Is actually a rigorous estimation, and I've done it. Since it's actually a presentation, I couldn't capture all of them. So if one is interested, I can forward the estimate to the person. So I resolve it into the components, and then I combine the components together to give me equation, the equation on the next page after this page on the slide. I think that should be either 6.3 or so. So that's how I resolve it, and then I combine the two Lyapunov functions together to get the system that I got, where the eigenvalues are both negative real parts. That's how I validated my findings, sir.
Okay, okay, I think another question, which is the last one here.
Thank you, Dr. Jackson, for the talk. I would like to ask, my first question is, what informed this investigation? Like, what was the motivation behind this? That's number one. Number two is that how can you be looking for stability locally and globally when you have not shown us whether the solution, you didn't show existence and uniqueness of the solution? Thank you.
Okay, let me begin from what motivated this research was when I look at Agarwal's research in 2015 and 2018. Agarwal in 2015 established a system of Caputo fractional derivatives using scalar Lyapunov function. And then in 2018, he established the stability of system of Caputo fractional differential equation using an impulsive term, that's without term, still using scalar Lyapunov function. So what I did was to extend that work. First of all, I needed to understudy the vector Lyapunov function in the classical sense of it, as was argued by Lakshmikantam in, I think, about 1974. So I needed to understand vector Lyapunov function from the context of the classical derivative. And then what I did was to now use that understanding to extend this, because up till this time, the research gap was there that there was no system of fractional derivative that was explored using the vector Lyapunov function in the sense of stability. So that's what motivated the research. The second aspect of it was that the second aspect of hello, sir.
Yes, you are with you.
Please, maybe you will have to remind me about the second question again. Actually, I needed to start from the second.
How can you go that you went ahead and you are trying to establish stability, even though we are still supposed to look at that, but then you are trying to establish stability.
Okay, establishing existence and uniqueness. Now, first of all, existence and uniqueness is actually assumed in the context of this presentation. It is assumed that the system, the solution exists and is continuous. Why do we say so? The function we are adopting is actually continuous, and the continuity of the function actually speaks of existence of the solution of that function. So we assume existence from that context, and then we kick off from there to establish the stability. So in my work, I didn't establish existence. I merely assume existence based on the fact that the function I'm adopting is continuous.
Hello,
I don't know if that is an attempt on your question, sir.
This is not mathematically conventionally accepted, because you cannot, in the simple, you have an initial value problem. I can see that initial value problem. And from your initial value problem, I mean, the initial value is not even known, and that's a big problem. Maybe you don't know this. If you look at your initial value problem, it's not known. When it's not known, it's a big issue for you. Now, and we don't know the initial value. It's unknown because we just use the particular variable, which is we don't know whether that value is negative or positive, or we don't know even where it lies. We don't know, it's not defined. So now I'm saying that you are assuming the very big question around that. So if you don't establish existence, that means you didn't tell us whether the system is well posed. How can you come up as you are finding stability? Now, because everything you want to do before you do the existence and uniqueness is based on that. It's based on those existence, uniqueness, and whether the initial whether the solution depends continuously on initial data. So these are things that you don't just say you assume. No, as a mathematician. Thank you.
Okay. No, my prof, we assume in mathematics. We assume.
I think that one of the things that prof is
the assumption is not in abstraction as for. First of all, I want to maintain that, my prof, I want to maintain that, first of all, we assume in mathematics, but the assumption is not in abstraction.
Assume in maths that when you are trying to transfer from the real world into the abstract world, but now you have a system. Now, by the time you put up a system, you should show us whether the system is well posed. If you don't show well posedness, how can you say that you are doing stability? You don't assume well posedness. Are you getting me now? If you argue that, we will leave you to that. It means that you don't want to learn. So we will leave you to it, but we will say our own and it's recorded. Okay? So if you argue it,
no, my prof, I am not. I'm only making a contribution. It doesn't necessarily mean I don't want to learn from you. I am. I'm open to learning. I'm sorry, my prof, if I'm arguing with you. I'm sorry, my prof. I'm sorry, my prof.
To show that you don't know the primary basis in mathematics, for you to argue that you are to assume well-posedness, it's a question around you. If you are assuming well-posedness, it's a question that the basic thing is not known as a mathematician. Thank you.
I think it's like we have said that the essence of conferences is for people to come and then learn and take feedbacks as well. And then in case there's something that's not clear, you can simply just ask questions as to maybe the way you view it. In any case, I think the prof stand is already made known that that is not supposed to be assumed. If it's not an established model already whose posedness has been built elsewhere, where you now want to say that, yeah, based on the fact that this has been established. So I think that's the issue. I think he also pointed out something very crucial that you're supposed to pay attention to, that has to do with your initial condition. It is not condition. Like your initial condition is not constrained at all. It's left hanging freely. It's just saying,
okay, the initial condition we're supposed to carry values.
So you are supposed to put a kind of a constraint. You are supposed to constrain it. Is it negative? Is it positive? Is it non-negative? You are supposed to let us at least state it. That is what makes the initial condition well stated. When you just say that, for instance, you say x of t not equals to x naught. I've not said anything. But I don't know anything about x naught. Is it greater than 0? Is it less than 0? I don't know. Anybody can make it be anything. And then the problem becomes terrible because we are talking about a biological system here that should not be negative. I think that's what one of the things is pointing out. Just take note of it.
All right, Doc. Within the context of the work, the initial condition is positive, not negative. I was supposed to assign a value to it. I take the correction, my Doc. Thank you so much, sir. I was supposed to assign a value to it. Thank you, my Doc.
Thank you. Yeah, thank you so much. Good presentation. Thank you so much. Please let's appreciate him.
Thank you, my prof.
All right. So can we have the next person now? Said Musa, are you there? Still. No. So we have any other online presenter who is available for presentation?
Yes. Hello.
Hello.
Okay, yes.
Hello.
So you can share your screen. Please, Dr. Jackson, please, can you help us remove, just share your screen, please, so that others can share theirs.
No, it's no longer sharing.
Okay, oh, sorry, I'm having it. Okay, we're the one sharing. I'm having it shortly. Yeah, sorry, thank you.
What's his name? The person talking should identify himself.
Please,
I'm about to share my screen, but it's not just.
You are using your phone. You are using your phone.
Yeah, but I have PowerPoint version of my presentation.
Yes, don't use your phone, please. And if you are using your phone, put it on landscape.
Okay.
Put it on landscape. You put it on landscape, we can see better, but here we cannot see it. And then it's also saying that this file cannot be previewed, it might be completed, corrupted, or something. So, do we have your presentation with us? If we have, we can share for you.
Yeah, I sent it via the chat, but I don't know.
So, okay, so what name did you use to send it?
I sent it as PowerPoint P and other characters, but PowerPoint P.
PowerPoint P. Okay, so can we locate PowerPoint P and help him to share that? Okay, did you send it to the email address sent?
No.
Where did you send it?
To the chat on this very platform.
No, we ask you to send it to email. There's an email address that was given you.
Okay. Please check if there's any.
Is it on Zoom you sent it?
Yes, on Zoom, on this very platform. Yeah.
Oh, you are not supposed to do that. It should have been sent to. Please, if you have any other person who is ready while we are waiting for this one, can we take another person? Don't worry, we'll try to look for. Okay, PowerPoint. Is it PowerPoint presentation?
Yes, PowerPoint. That's it.
Okay. Now, let's have it, please. Let's have it projected. And please, you can unshare so that you can share from you.
All right, thank you.
Please, other online presenters, I think 2 of you that are left, signify so that we can take care of your presentation, because after this session, we are going to end all presentations. So I think we have dedicated today entirely for online presenters, and I think we have done well in that. So for those who are not on, because I have seen many times some of us say we have been online, but you all agree with me that we have also been calling and you are not answering. So some of us, I know what we do with online presentation. Sometimes we drop it, we open it and go and do something else. You are somewhere else, the phone is somewhere else or something. And then when you are called, you are not there. And then you come back and say you have been online or you were called. So please, when it comes to this, we may not take responsibility for your inability to present. And I'm saying this now so that for some of you that have been coming to us and saying that we are not allowing you to present, please stay online and then let's have your presentation. So what's your paper code? Is it? What's your paper code?
It's AM07.
AM?
07.
Which is AM? APM 07, okay.
Yeah,
This person should, if is this what you send? This is the PDF. I think I've said, please.
I am trying to even share from my end because I have the PowerPoint version, and that's what I.
What you want to share is a PDF. It's a PDF. You only broke it into. We are told that presentation should be made available in presentation mode. Not that you give us a PDF of like a full manuscript. Like a full manuscript. And then that's what we want to show us. No, it's not good. We are not going to take this.
I'm so
we are
very
not
sorry.
accepting that this.
The whole thing was just, I'm not even supposed to be the one to do the presentation and one of the authors. But because we had an issue with the document, we just have to come up with.
I think you should sort that issue out. We don't want to start this kind of thing. We'll be taking.
Okay, thank you.
Said Musa, are you ready now?
Can you now hear me? Just got
Said
back.
Musa, right?
Yeah, yes, the network kicked me out. Just got it back.
We can hear
Okay,
you
please
now.
let
We
me
can
do
hear you.
share.
Can you share your screen? Can you share your screen, please?
Thank you very much. Let me do the share.
All right,
Yes.
please share your screen.
Once we allow it, no, that means what I was doing.
Are you sharing the screen?
She can share it from.
Can you see my screen now?
This sharing.
Hello. Hope you are seeing my screen.
So go to the slides.
We are
I
seeing
am on
your
the slide
phone.
now. It's shared.
It's your phone that we are seeing. You are sharing your phone with us. You are not sharing your slide, but it's your phone that you are sharing with us. Your contacts, everything is what you are sharing with us.
Oh.
We are not seeing your slide.
Is your slide with us?
I'm coming, please.
Is your slide with us?
Oh.
Have you sent your slide so that
Yes, I have sent.
on your behalf?
I have sent.
Okay,
You
so
can use the
what
other
did you
one.
what did you save it?
Can you use the other one?
What did you use to send it? What name?
Said Musa Irima, that's the name I gave it.
Said Musa. Okay, please locate Said Musa slide and show it on his behalf, please. Said Musa.
Zoom chat.
Zoom chat. Thank you. So if anyone, anybody decided to send them, any two of us send the slide and come back quickly. So for sure, come in. We have one live.
You see the same from the same.
Okay, so Said Musa, you will just
But I
follow
sent their
our.
email.
Yeah, you know, we are presenting for you now. So we'll be presenting for you now.
Did you not? You didn't see it.
We have seen it, and then we'll be presenting for you now. All right, can you start your presentation now? You have 10 minutes.
Okay, but I'm not seeing anything. Okay, now I'm seeing it. All right.
Have you seen it?
Okay, that is the topic or the paper. That's the title of the paper I'm presenting. AOA means Angular Variable Based Passive UA localization for 5G aligned for urban air mobility. Huh? So I'm Said Musa Erima. With me are other two contributors, Abubakar Bala and Hassan Aliyu. The next slide, please. Next slide, please.
Just a minute.
Next slide, please. Next slide again. This is no problem with this. Next slide. Now. So the main thing about this presentation relates to surveillance system. No, the slide you just left off.
Wow, yeah, it's gone.
Yeah, go ahead.
Yes, gone. Network. Somebody is on standby now. Mr. Mohammed.
Said Musa, are you still here? Are you still here?
Mr. Mohammed, ready.
Okay. We can. Is it? Please check. Is it on the call? It's no longer on the call. Okay. So who else is ready for presentation?
Yeah. Adamu John.
Who is ready? Adamu.
Is Adamu there?
Is Adamu there?
I'm right here. I'm right here, sir.
Okay, good. So we are going to be presenting your slide.
Okay, thank you very much.
All right. So
HBV.
Now you have 10 minutes to present HBV transmission dynamics in Nigeria. Am I right?
Yes, that's very correct.
Okay. So you share the screen. Right.
I can't see the screen.
Hello?
Can you see it now?
Yes, this is not the work I shared actually. The most recent one I shared.
Transmission dynamics in Nigeria, mathematical modeling with 8 targeted vaccination.
Yes, but this is not the precise. That's the one I've touched. The one I sent.
So but this is what you sent to us. Which one are you intending to present?
Can I share my screen?
Okay, share your screen.
Okay, thank you.
Oh no, very not.
I'm getting a message that the file cannot be previewed.
Are you not? We sharing screen now.
I'm trying to share this, telling me that I can't. It's that the file cannot be.
Now that's the challenge. That's the challenge. You see now, you are using form to present. It's not showing. It's not working well.
So okay, let me just go ahead.
maybe you should resend what you said. If you
Okay.
are resend the correct one.
All right.
Okay, so while you are doing that, another person is here. Heat mass transfer and entropy generation in pulsatile non-Newtonian nanofluids between porous channels, a spectral relaxation of which is Ayegusi there? Please unmute if you are there. Ayegusi, are you there?
Yes, I'm there. Can you see my screen?
Okay, good. We can see your screen. Please, can you put it in presentation mode? Full screen so that we can see it properly because it's not that clear.
So I've just resent the correct version of my presentation.
All right, fine. We'll take you after this presentation. So please, Ayegusi, you can go on. You have 10 minutes. Thank you.
Okay, thank you very much. I hope you can hear me.
Okay, we can hear you very faintly. You can increase the volume. We appreciate it.
Okay. Good afternoon, distinguished professors here seated, researchers and students. My name is Ayegusi Florence Dami. The title of our work that I want to present is Heat Mass Transfer in Pulsatile Non-Newtonian Fluid between porous channel, a spectral realization approach. My abstract. The purpose of this is to investigate the effect of entropy generation of some embedded physical properties on heat and mass transfer.
We can't see. Can't hear we pass.
Pulsatile flow of non-Newtonian fluid.
Hello, Ma, we can't hear you.
I said the purpose of this study is to investigate the entropy generation effect on heat and mass transfer in pulsatile non-Newtonian nanofluid flow between two porous parallel plates in the presence of a Lorentz force. And our methodology is governing with partial differential equation. We're not dimensionalized and solved using spectral realization method, which is one of the numerical methods. And our results, we have our velocity and temperature profile being used to compute.
We can't see your slide very well.
I shared my screen. I've shared my screen.
Hello, Ma, can you hear us?
Yes, I can hear you. Can you hear me, please?
Is your voice
I shared my
very
screen.
low?
Can you hear me?
Stop it to increase your volume.
Hello?
Yeah, hello.
Can you hear me now? My screen is.
Maybe you. I want some.
Okay, so what we two things you should do for us. Two things you should do for us. Please let Ayegusi finish our presentation before any other person shares. Don't interrupt, please. So, two things you should do for us. Increase the fonts, please. We cannot see the font is very small in this place. And then you should also increase the volume of your voice so that we can hear you. Because what you are sharing is very tiny in this place. We cannot see it. So, or let's share for you if you have sent to us
please
already.
do.
So, what's the name you used to send to us?
No, take that.
Slide presentations.
Okay, are we present? Okay. Okay, we have seen this the thing.
I use slide presentation as the title of my slide.
All right.
So, our methodology. The governing partial differential equation were not dimensionalized using suitable dimensional quantities to transform the PDE into a system of coupled nonlinear partial differential equations. And the resulting equations are solved using spectral realization methods due to the effectiveness and the accuracy of the method. Here we obtain velocity and temperature profile and use to compute the entropy, generation rate, and Benjamin numbers. The influence of various flow parameters on the velocity, temperature, entropy, generation rate, and Benjamin numbers are discussed graphically. The results indicate that the energy losses can be minimized in the system by choosing appropriate values for pertinent parameters when thermal conductivity is increased, which led to the depreciation of entropy generation. And why this increments in thermal conductivity appreciating the Benjamin number, the Eckert number on the entropy generation and Benjamin number, then the graph shows that each time of increasing in Eckert will lead to the rising of the entropy generation. While this increase shows reduction in Benjamin number, to shed more light, the results were further demonstrated graphically. Then the current research was very supported by prior literature's work. Values and originality, all the results presented graphically, and the results in these articles are anticipated to be helpful in the area of engineering. Introduction. Several models describe non-Newtonian fluid, including coupled stress fluid model. This theory, introduced by Stokes in 1966, accounts for polar effects and is applicable to fluid with microstructure such as lubricants, polymer, additive, liquid crystal, and blood as very good example of this. Then, under literature review, we have various people as work in this area. Somebody like Akhtar and Seller 2018, Farouk Ito 2013, Rundara 2018. Then we have Khalid 2018 as well, Ayegbus and Ido 2023. So many people as work in this area that shows that the movement of this fluid shows that they demonstrate non-Newtonian fluid, including Carson fluid and so on and so forth. Then, considering this work, we investigated the effect of entropy generation of some embedded thermophysical properties on heat and mass transfer of pulsatile non-Newtonian nanofluid flow between two porous plates with varied thermal conductivity and viscosity on heat and mass transfer. This is not realistic because as fluid move, their viscosity and thermal conductivity change. Studies of this type find application in numerous engineering applications, such as food processing, drilling, magnetohydrodynamics, accelerator, chemical catalyst reactors, and so on and so forth. Moving down to the model formulation. An unsteady coupled stress non-Newtonian and electrical conducting incompressible flow between two parallel penetrable plates is considered in this study. Our S and Y axes are the transverse and perpendicular axes. You can see from our flow geometric diagram, S and Y axes are the transverse and perpendicular axes to the flow direction. A uniform magnetism is considered to act along the y-axis, and the liquid is injected into the lower wall at y is equals to 0, into the upper wall at y is equals to L, having uniform velocity. The number is presumed to be very small, hence indoors magnetism is foregone. The fluid are electrically and conductive. We summarize that all liquid properties are constant except the liquid density and internal heat generation, which are temperature dependent. Now, we look at the system of equation. Equation 1, we have equation 1, equation 2, equation 1, which is part of the governing equation. All these systems of equation are part of the equation that we consider. We have concentration equation, we have energy equation, subject to the boundary condition. So from equation 1 to equation 7, these are our systems of equation and having the boundary condition. Now, and the order signifies the Asia velocity time. Most times we have liquid temperature, we have liquid concentration, and the pressure respectively. We also have a symbol that signifies the fluid density. Our V naught signifies our suction or ejection term. We have beta naught that stands for the electromagnetic induction. We have our method of coefficients of volume expansion due to the temperature as well as concentration. We have thermal conductivity. We have radiation time as well. And we have diffusivity. All these ones are what we incorporated into our system of equation. Here, the heat flux for an optical thin fluid takes the form of heat emitting from the liquid. That is represented in our equation 8. Now, we also have some other non-dimensionalized variables that are involved on the governing equation according to Hayat et al. 2012. That one is in equation 9 and 10. The aspect of entropy generation analysis is used to forecast the performance of the engineering process. The second law of thermodynamics governs the method for entropy generation analysis, while the contribution of the 6 sources are shown in the equation below for local entropy generation. And due to the heat transfer, we have our radiation fluid friction, we have magnetic field and mass diffusivity, and represented by the 4th, 2nd, 3rd to 6th terms respectively. The numerical method that we considered in this work is spectral realization. Because of the accuracy of the method, the dimensional system of partial differential equation is solved using the spectral realization method called SRM, and follow the iterative steps of Garcia type of realization approach to linearize the decouple the system of coupled differential equation. The linearized differential equation are discretized further and solved using Chebyshev's Federal method by Mostar 2012. We have our local entropy generation signified under equation 11. Then we non-dimensionalize the variable on equation 12 and 13. These are what we use to dimensionalize what we have in our equation there. We also have dimensionless entropy generation. These are the terms that we derive after we've already dimensionalized our entropy generation equation. So we have that one in equation 17. Then we have some parameters that we're able to derive from what we have after we dimensionalize. We have the parameters like radiation parameter, Brickman number, dimensionless temperature. We have thermal conductivity, radiation as well. Then considering the effect of thermal conductivity on the velocity, look at figure 2 shows the effect of thermal conductivity on velocity and velocity profile that is being distributed plotted against time. And it was observed from the graph that the maximum fluid velocity occurs at the highest value of the thermal conductivity parameter, while the minimum velocity is recorded at our alpha is equal to 0.1, which is denotes our thermal conductivity. This trend is consistent with the previous studies and indicated that increased thermal conductivity enhances the velocity profile of the fluid flow. Now, also consider the effect of all these parameters of coupled stress parameter on velocity. We have that one in figure 3, effect of coupled stress parameter on velocity and velocity profile distribution plotted against time. We discovered that the effect coupled stress on the velocity that denote the coupled stress, which is well being verified from the scholar as well. We discovered that the coupled stress parameter on the graph is observed and increased the also in figure 4, we have the effect of thermal conductivity and the effect of it on Benja number. From what we have, from here we can see in our graph.
Hello, ma. You have 4 minutes more. Thank you, ma.
Okay, shows that increased thermal conductivity led to a reduction in entropy generation, while Benja number increases as well. Then also effect of coupled stress parameter on entropy generation rate for coupled stress on Benja number we discussed in figure 5 illustrate the increase the coupled stress parameter reduce entropy generation and increase Benja number. Also, effect of Ecke number, we also consider that one. It shows the increased Ecke number leads to the rise in entropy generation while Benjamin number decreases. And we also have the effects of the amplitude parameter as well. Both on the we also check for the Benjamin number, indicate the increase in amplitude, reduce the entropy generation, and increase the Benjamin number. In summary, as the summary of our finding, this study investigated the unsteady heat mass transfer characteristics of a couple strain on Newtonian nanofluid flow, two parallel porous plates in the presence of thermal radiation, heat generation, viscous dissipation. The governing partial differential equation were not decimalized using appropriate similar variable and solved numerically using SRM. The influence of several embedded physical parameters. One, increases the coupled stress parameter, reduce the volume profile as the fluid approaches this channel. Two, for gaseous fluid, an increase in the variable viscosity parameter enhance the velocity profile. Also, we have at high magnetic field strength, the Lorentz force intensified led to significant suppression of the velocity profile, and an increase in Ecke number thickly determine boundary layer as well, thereby increase the temperature. The higher values of the thermal Gratian number result in enhancement of the fluid velocity. We have, so here are my references. Thank you for listening. Hello, can you hear me?
Network, yes. Are you with us? It's now time for question. We want people to signify if they have questions now, so that I'll take them. Questions, question. Physical or online question. Okay, let me ask a question here. All right. What is the physical problem that we are trying to solve here? Now, yes, the matter is very wonderful. But what is the problem?
Yes.
Physical problem as far as the fluid, heat, and all of that is concerned. What is the problem that we are trying to look at? And what is the finding? Like summarize that in a language that even non-mathematicians can cope with. Thank you.
It's not a language.
Okay. Did you hear me? Hello, are you there? Hello? Hello, are you there? Please, can you help me confirm if she's still online? Okay, that's what it is.
Hello.
Shows online again. I'll find online. Let's take the next episode.
All right, let's take the next person. Since you can't get her again, it should have been good you stay for your for comments and questions. Next time when you want to present, don't just make it about presentation. We don't appreciate that. Please present and wait for question. Wait for question. Feedbacks from people. That's what is called conference. All right, thank you. So who's the next presenter?
Mukhtar Ibrahim.
Okay, Mukhtar Ibrahim, are you there?
Hello. Are you hearing me?
Yeah, we will
Hello?
share your slide for you from this place.
Hello?
Like me to share your slide. Okay, do you have your slide? Can you share it? Mukhtar Ibrahim.
Yes. Yes.
Can you share your
I can
slide?
have it. Okay, let me share it. Yes, I have it with me.
Okay, so let's have it.
Is it visible now?
Not yet.
Hello? Not yet.
Not yet.
No.
We can't see it. Yeah.
Yes.
Okay. Can we attempt sharing from him?
You have the slide.
Oh, you didn't
Okay,
even
sir.
send your slide.
No, I have sent it.
So
I have sent it through the mail.
to the email address. What did you use to save it?
The name of the title of the paper, Adoption and the Use, Adoption of Artificial Intelligence.
Adoption, right?
Adoption, yeah.
Okay. So can you get adoption for us? Okay. Yeah, we have seen it. So present on your behalf and then you can just follow.
Okay, sir.
Okay, so we are. Can you see it now?
No, not yet.
Okay, it's coming up. Okay. Can you see it?
Not yet, sir.
Please confirm that you can see it.
Yes, I can see it now.
Hello,
Okay,
can
so
you hear me?
let's have it. So you have the floor.
Hello?
Yeah. Hello?
Okay.
Can you hear me?
Yes,
The
I can
session
hear
has
you.
ended. We were asking questions, but we
Hello?
couldn't get you online. Answer those questions.
Hello?
So that
My
session is
network
over.
got me.
Another presenter. Yes, another presenter is all now. We're trying to ask some questions, but we couldn't get you to answer them. We're not online again. So, but another session is on already.
Okay.
So
May I start,
Mutari
sir?
Ibrahim, please. Mutari
Yes.
Ibrahim, please.
Can you hear me? Can you hear me, sir?
Yes, we can hear you clearly. Mutari Ibrahim, please go on.
So, good evening, all the members
minutes.
of the. Okay. So my topic is adoption of artificial intelligence in library and information centers in Katsina State, Nigeria. Here's the outline of the presentation: the introduction, purpose, and the significance of the study, of the review, objectives of the study, scope and the method of the review, challenges, opportunities, implications, conclusion, and recommendations. The first one is the introduction. As we well here know, libraries is a backbone of any institution or organizations. Libraries can take all the responsibility of producing the good products of any institution. So as historically, libraries serve as a critical institutions for the organizational preservation and dissemination of knowledge. Therefore, AI refers to any simulation of human intelligence in machines capable of learning, reasoning, and adapting to new information. Also, in Africa, and specifically Nigeria, the adoption of AI in libraries is still in its early stage. Although awareness is growing on ongoing libraries, but many institutions lack infrastructural facilities and the funding necessary for full implementations. The purpose and the significance of this review is to analyze the current trends, challenges, and the opportunities in adopting AI within library and the information centers, precisely in Katsina State, Nigeria, by signifying the objectives to achieve. Number one, to examine the global and regional development in AI-driven library operations. Number two, to assess the current level of AI awareness and the adoption in Katsina State, Nigeria. Number three, to identify the key challenges hindering the implementation or adoption of AI in libraries or information centers in Katsina State. Number last is to recommend the practical stages for implementing or adopting AI in libraries and the information centers. Therefore, by doing this, the scope and the method for the review is the review is the best literature review approach, synthesizing professional sources publishing between 2020 and 2025. That latest or current scholarly publications. The opportunities for the implementation of AI in libraries and the information centers is it enhancing services delivery, example, SDI, CAC, DDS, etc. Number two, data-driven decision making. By using AI, the management or the libraries may come up with a new, a tangible, a reasonable, or a outdated means of management. Personalization. It also allows users to have their own user interfaces by what? By allowing them to ask and to search by themselves. AI may allow them to do all those processes. Collaborative activities by implementing or adopting AI in libraries. Libraries might come up with the collaboration between one library to another, between one organization to another. Then policy development may help, may guide the organization or libraries to come up with a new policy formulation or development. Implications for library practices and the policies. By implication, when libraries are not adopting this AI development, libraries might remain where they are. They will not become developed. By using this, it will simplify their tasks, their processes or tasks that are daily routines for the libraries. In conclusion, AI presents a transformative opportunities for libraries in Katsina State to enhancing efficiency, accessibility, and user satisfactions. Recommendations: by implementing AI in libraries or information centers, capacity building might become most number one considerations in building their resources and their staffs to come or to build their services in libraries or information centers. Number two, infrastructural development. Infrastructures must become number one priority to be for charge to implement in libraries and the information centers. Policy framework must become number one aside to provide for the implementation or adoption of AI in libraries and information centers. Funding must also be available. Then collaboration between the library or information centers must also be considered. Awareness and the campaigns must be aware. Peoples and organizations or libraries must become aware of the AI implementation or the adoption in libraries and information centers. That's the end of the presentation. Thank you for listening.
Well, thank you so much for your presentation.
Thank you, sir.
Okay, let me ask, is this supposed to be a systematic review?
Yeah, sir.
Okay, no problem. Let me allow people to engage you in questions. So, questions.
Okay.
One or two questions. One or two questions. Said he has done a systematic review.
Every talk.
So, any question? Okay, since people are already happy with your presentation, no question. All right. I'm not seeing hands up. No hand is up for question, both online and physical. Okay, questions.
AI generation.
All right. So, our dear presenter, so for your systematic review, what are your criteria for inclusion and then
Next generation.
your inclusion criteria for the papers that you used. So we don't, I think you need to speak to that. How did you did you come about the papers, the literature that's included in this study?
Okay, by looking at the slides on the PowerPoint, when you are when you are looking for the slides that is talking about the introduction, it also cites all the scholars that has been consulted before formulating the paper. And the review.
I'm talking about in your methodology. It's a systematic review, right? If it's a systematic review, your methodology will necessarily involve your inclusion criteria and all of that. And then we'll see the papers that you put, how you're able to come about your papers, then what you're able to get from those literature that you actually reviewed. So one will be interested in seeing that flow of review that you say you did. One will be interested in that.
So there is a page separately for references, which is not included in the slides.
No, that's the key aspect of literature. I mean, systematic review. You can't do a systematic review. Yeah, very important. You are doing a systematic review. It's important that you show us how you came about the literature that were included, and then the ones that maybe you possibly excluded, and what happened. And then if those one included, you want to tell us the findings of each of those papers that is leading to the gap that you have been able to identify. I think you need to pay attention to that when you are doing systematic review. Okay, thank you so much.
Exactly.
Let's appreciate you for his presentation.
Okay, thank you, sir. Thank you, sir.
All right, so let's have the next presenter, Sanusi Suleiman. Are you there? Please, can you confirm that you are there, Sanusi Suleiman?
I am here, sir. I am here, sir.
All right, thank you so much.
Can you hear me?
Let's
I'm with
have
you.
the presentation of Sanusi Suleiman.
Can you hear me, sir?
The
I'm with you.
presentation of Sanusi, yes.
All right. Good evening.
Just hold on for us to have your presentation.
It's online, right?
Okay. Are you the one with next generation AI?
Yes, sir. I'm the one.
Okay.
Can I start?
You
Can I start,
you
sir?
have 10 minutes. You have 10
All right,
minutes
sir.
for your presentation.
All right, sir.
Let's go.
Good evening, scholars. Good evening, gentlemen and ladies. My name is Sanusi Suleiman, and the paper I'm about to present is next generation AI, advances in machine learning, robotics, and human AI collaboration. Next, please. All right, the background of the study, I summarize everything so that I will hit the point to avoid delaying and wasting much time. So, background of the studies. AI has moved from theory to real-life applications, and some of the impacts include. Please, can you go back to the previous slide, please? Sorry. All right. And some of the impacts include healthcare, education, industry, governance, etc. It has also shifted from automation to human-centered AI. I think that is the basis of this conference paper. All right. What's next generation AI? Adaptive and intelligent systems, human-centered and collaborative, combines machine learning, robotics, and human AI interaction. Next slide, please. All right, here are the objectives of the study. The objectives of the studies are to examine advances in machine learning, discuss intelligent robotics, explore human AI collaboration, and highlight ethical challenges. Next slide, please. All right, methodology. So the method we use in sourcing our resources are as follows: systematic literature review. That is, our sources were our sources were from authors from the year 2020 to 2025. We also got our resources from IEEE, ACM, Springer, Google Scholar, that is global database. We also got our sources from there. We also get our sources from that is thematic analysis. That is a method of analyzing qualitative data to identify and analyze, interpret patterns and themes. So we also adopted the method. So next slide, please. Advances in machine learning. Some of the advances include deep learning models, transformer and foundational models, language and image understanding. I think we can see some of the examples from generative AI applications like ChatGPT, deep learning, and the rest of them like that. Next slide, please. Application of machine learning. So machine learning are applicable or they are important in the following places: healthcare diagnosis and imaging. Of course, this is used in a hospital now, modern hospitals. Finance fraud detection. It is also applicable in banking, financial institution. Education personalization. This has to do with the academia. Cybersecurity threat detection, that is protecting critical infrastructural, that is a critical national infrastructure using cybersecurity methods and the rest of them. Next slide, please. Are you with me, sir? All right. Challenges in machine learning. Though machine learning has advantages, it also has its disadvantages. And one of it include data bias. That is, data bias refers to errors or distortions in data collection, analysis, or interpretation. And such bias can lead to inaccurate and unfair outcomes. So also lack of transparency when data has no integrity. High computational cost, that is the cost of establishing the cost of establishment, and need for explainable AI. When when complex algorithms are used to develop systems, there is need for one to explain until your audience understand exactly, or users understand exactly what the AI is doing. Next slide, please. All right, evolution of robotics. Robotics evolve from rigid machines to intelligent systems. That is the systems that we have today. Integration of learning and sensors. I think this is applicable in drones. You see, when drones have sensors and capable of detecting security threats in a society and so on. Collaborative robots. It has also evolved into collaborative robots. Application of robotics. We have healthcare and rehabilitation, service and customer interaction, autonomous drones and vehicles. This is what I talked about earlier, autonomous drones and vehicles. That is the ability for drones and vehicles to have sensors. They drive themselves, like we see today. We see vehicles that drive themselves. You see vehicles that drive themselves, drones that power themselves, and that detect security situation. All right, human AI collaboration. Human AI collaboration has shifted from automation to partnership. That is the ability of humans and machines to partner together and work together. Instead of machines to completely execute the work of humans, this is telling us that humans and machines can also collaborate and work to have effective service delivery. AI supports human decision making. Humans provide judgment and ethics. Next slide, please. All right, trust and explainable AI. Transparency improve. All right, ethicals. Okay, let's go to the next slide. All right, I have future directions. All right, future that is in the nearest future, we intend to have human-centered AI, stronger regulations, AI education and research, opportunities for developing economies. Next slide, please. All right, conclusion. Next generation AI is transformative, like I explained earlier. It combines machine learning, robotics, and collaboration. Responsible and ethical AI is essential.
All
All right, thank you so much. Please let's appreciate him for his presentation. Thank you for your time. Okay, before I hand over the mic in case for anybody who may ask have questions to ask. I know that Prof is still going to come up to address some of the challenges we are having with our presentations and all of that. But then I want to ask Mr. Sanusi, did you say this is supposed to be a systematic review?
Yes, sir.
Okay, just like what was said to the other presenter, as far as I'm concerned, I'm not seeing any literature in this work. Because it's systematic review, it should necessarily be literature rich. It should be rich in literature. You know, finding out what people have done, and you know, with a target to uncover a certain gap. After which the gap will be shown as a result of what we have found, and then in the end, you are going to be telling us where research should focus as far as that gap is concerned. But what you have shown here, you have not linked the work to any literature whatsoever, as if one is writing a note. And you know that when you do that, even if you have actually consulted any literature, it will look like as if you have just gone to copy something online, you know, to present. I'm not saying that's what you have done, but it will look like that. So it will be great that we look at systematic reviews, how it's done. There are papers that are written, they are not original research, they are systematic review, and they are wonderful. So I think some of these papers will be of help to some of us that are doing the systematic review. All right, I don't know if anybody wants to have a question or observation or something to a contribution to this work, so that maybe next time this person has to present, it can be better. Okay, all right, thank you.
Thank you, sir, for your presentation. In contribution to what Dr. Rashko has said, your points or bullet points are not cited. And then we don't know the number of literatures you actually reviewed. So these are some major things about literature review. How many literatures did you initially gather? How many did you eventually review? Why did you decide to review those literatures? And there's this PRISMA method that they use in literature review. When you follow the PRISMA steps to selecting your literature, it enriches your literature review. Thank you.
Noted. All the observations are noted. However, some of the observations that you raised, I have them in the complete paper. I can share with you if you want to have it, so that I can.
Thank you so much.
From there, I can know my area of improvement, and I'll do better in the nearest future.
Okay, thank you so much. All right, please let's appreciate him for his presentation again. Okay, so how many people do we have?
Said Musa for now.
Okay, the last person, I think, Said Musa.
Yes.
It looks wonderful that towards the end, as if everything was arranged. That we maths. Now we are having something AI. Okay, no problem. The word is going AI. So we have Edge enabled AOA. Is that the title of your presentation?
Yes, exactly.
Okay, great. So let's have you, Said Musa.
Thank you very much for having me. Yes, I'm very sorry for the network flipping in and out. Thank you very much. Just like you said, the title is HNW. AOA means angle of arrival, base passive UAV for unmanned aerial vehicle localization for 5G align urban air mobility. So the next page. Okay, these are the content of this presentation from introduction down to conclusion. Next page, please. Now, so the main thing about the whole thing about this research or this paper, this presentation is about surveillance system. We want to solve a problem in surveillance system. And all those surveillance systems, they are very broad. It can be passive, it can be active. When we talk about satellite to localize, we're talking about active. But when we are receiving signals that are emitted by the devices, airborne devices themselves, we receive them and process to be able to know the direction in which the signal is coming, and using the direction to determine the exact location is called passive localization. So you see, this has to do with a lot of things about direction finders. So the next slide shall show direction finders. Next, please. All right. Before you turn to this page, you find out that there is something I mentioned, multilateral iteration. So this is an example of multilateral iteration. It's an example of localization system. And it's not the one I'm working on, it's part of the literature, right? It uses what is referred to as the time difference of arrival. That is a signal, a signal from the same source touches on all those antennas, but they touch on different or at different times. All right, the difference between the time on the first antenna and the successive antenna is called time difference of arrival, and we use this technique to determine the location of the emitting object. Okay, next slide, please. All right, when we do, why do we need to track signals? Why do we need to find out? Why do we have to have information on the electromagnetic spectrum? Is because we want to know, we want to do surveillance, we want to do electronic warfare. Right? It's not yet time to deal with these kind of things here, but actually in broad senses we do spectrum analysis to be able to conduct localization. Look at the stops here. You see you have antenna here, you have parameter estimation. Okay, and I want to work on this parameter. What are those parameters? They are the angle of arrival of the signal, power of arrival of the signal, time difference of arrival, the frequency of arrival of the signal. Once I know this, I'll be able to perform localization either based on TDOA or RSS received signal strength or angle of arrival of the signal. Okay, the technique are either the algorithm, we call them multi-angulation, multilateration, fingerprinting. Okay, next slide, please. Right, you see, this component are used for direction finding, right? Now, in classical localization, if you want to find the direction of anything classically, ordinarily, you use direction finder. You can just hold this by your hand and rotate. You can find the direction. While the beam is highest, maximum, you can find out that that's the direction of the incoming signal. Now, the next one is showing, that is figure B, is showing you an antenna array. If you want to maximize efficiency, you can use an antenna array. When you have combination of antennas like this one that looks like a triangle, it's called triangulation. You have one antenna, another antenna. If you form any two with the device that is transmitted at the other end, you form a triangle, and it's called triangulation. Next slide, please. All right, so localization approach are divided into so many. Okay, for instance, like this one, this approach, I call this one a two-stage process, whereby I have to estimate the PDSP, means position dependent signal parameter. That is, if you know the signal parameter, you'll be able to know the location of the transmitting object. Is that? So that is the two-stage process that is shown here. Next slide, please. All right, so I am not going for multilateration, I'm not going for fingerprint, I'm going for multi-angulation, right? So this figure here shows multi-angulation system. If you look at that green, an AOA is estimated, all right? When I estimate AOA, what do I do with it? I can use either classical approach or advanced resolution technique. If I'm using classical approach, this is where I'm using things like correlative interferometry, like Watson-Watt's technique, like pseudo-Doppler, like maximal likelihood approach. But if I'm going to advanced approach, these are what we call advanced resolution or subspace technique, like music, multiple signal classification, Esprit, estimation of signal parameter via rotational timing, all these kind of things, okay? But I am interested in using music for a purpose. Okay, next slide, please. All right. This is the simple geometry of how the direction of an incident signal can be calculated. It's a simple mathematics at this level. Next slide, please. All right, the arrangement you just see before here is a single arrangement. Now, if you combine all this arrangement into 4, making a square, you find out that you have a complete multi-angulation system. Multi-angulation system can be described by equation we call line of bearing equations. That is called the multi-angulation algorithm. The number of antennas is called the number of equations. In this case, the number of equations are more than the number of solutions. So we have what is referred to as over-determined solutions here. All right, next slide, please. Next slide. Okay, here is a problem. The problem is very physical. It's for everybody to appreciate. because of the alarming rate at which we are deploying drones now, and new drones that have been manufactured by different countries, the DJI, the DJI Mavic, the MQ Reaper, the Global Hawk, all these kind of things, okay, they part of the space. It ordinarily is telling us that we need to have some system that is very accurate, algorithm that is very accurate with low latency and be able to scale. Let's be able to scale this process into smaller chunks so I'll be able to perform localization, okay? So the objective here is to design a localization system which in the architecture, we are able to enhance the architecture based on edge computing on a 5G channel, right? And the next objective is we're going to use, we are using a music algorithm, is that multiple signal classification. And before using the multiple signal classification, or after using the multiple signal for estimation, we're going to use Kalman's filter to filter the
4
signal.
minutes more, Sam.
How many minutes?
4 minutes more.
1 minute. Okay, let me go to the result. Just help me get to the result. All right. I can't talk about the mathematics. Okay. The result. Forget about the simulation parameter. Just the result. Let me talk about the result. Next. Next. Okay. Now from the result, you can say, okay. No. No. The first result. In 1 minute, quickly, you can see this is the AOA. Since I am measuring angle of arrival, the angle of arrival must come with some error. The error is due to noise, whereas sometimes due to placement of the GRS. GRS is the receiving station, okay? So now if you look at the relationship between the AOA error and the AOA error variance, which the variance is a function of the power estimated of the signal, is somehow linear. So also if we measure the angle of arrival with respect to distance, UAV range means the distance at which the UAV is being targeted. You can say it's not linear, of course, but actually increases with increasing, even though not straight. Next slide, please. All right, here you also see the RMS related to the SNR, which is the signal to noise ratio. The better the signal to noise ratio, the smaller the error. All right, since I am upgrading from 2.4 gigahertz to 3 gigahertz because I want to go to what is a part at the 6G subband, all right? That is where I want to do the edge computing. That's why I'm doing the edge computing. I find out that it is better if I include edge computing. That is why the plot you see in red having better AOA SMR performances. Next slide, please. This is just NSS distribution in 3D as you go around, as the distance increases, that is in 2 dimensions. Next slide, please. All right, this is how by employing edge detection, I am able to scale down position RMSE, root mean square system. Is that root mean square error? Is that the edge computing enables me to perform computation at the very inside or at the very near the processing point, not at the cloud or not at the central processing station. That is what the first graph is. The graph C is telling you. Now the overall UAV performance, which is a ratio, is showing for the AO accuracy here, the range, the edge benefit, and the frequency. Again,
okay, you see. Random, sir.
Okay, thank you for it. And conclusively, what I am able to achieve from this is I'm able to implement Kalman's filter. I was able to implement edge detection algorithm. It worked. I'm able to implement what we refer to as a temporal correlation to be able to reject outliers, to be able to use multi-snap temporal fusion to be able to achieve all this, and that's how it works. Thank you very much.
Okay, thank you so much. Thank you. Presentation. Okay, let's ask him one or two questions before we come to the end of all the presentations. This is the last presentation that we can take. All right, thank you.
Yeah, question,
Any
sir.
question?
Yes,
Okay, go
question.
ahead and ask. Go ahead.
Yerima.
Yes, sir. Yes, sir. Dr.
Yeah.
Ladoja, go ahead, sir.
No, this is not Dr. Ladoja. This is Tijani.
Okay. Can I go?
Oh, sorry.
Okay.
I saw Dr. La. You didn't raise your hand. I was trying to look at the people that raised their hand. But go ahead. Go ahead. After that, Dr. Ladoja will ask his question.
Okay. I'm sorry, Doc.
Yes.
Yerima,
Yes,
you know,
sir.
this is, we're talking about signal. And
Yes.
I can see in one of your images there, right? You showed what? Transmission, and you show receiver. Do you take
Exactly.
consideration of the challenge? And you know,
Of course,
normally
sir.
in
Yes, exactly. I did what is referred to as
in
link
you know,
budget estimation. I did that.
okay, budget estimation. You know,
budget.
attenuation is the factor of
Exactly.
this signal,
Exactly.
right?
I'm using
Do you
free
take
space particles. Mm.
okay, but you did not factor it out.
No, it's just this. I cannot put everything because actually this kind of work, I was working on the paper, not knowing that we are not just showing paper, we are going to show slides. So I co-opted everything this very night. Is that the last night? It's like in a rush. There's a lot of information I cannot put here.
Okay, please take it in major. Anytime you're talking about
Exactly.
signal, please make sure
Thank you.
you always out. Thank you.
Thank you. I appreciate, sir.
Okay, thank you so much. Dr. Ladoja, now can you unmute yourself and then ask a question?
Thank you very much. And thank you for that wonderful. I'm really interested in that. So I want to ask some questions. I think we should, from your problem statement, I was impressed. And we should see that some of these drones are already being used in the Western world as a form of delivery that is even solving their logistic problem in the Western world. Have you tried to consider how it can be localized in Nigeria? Maybe you have considered the stricter strength in this area of in this part of the world. Can this really work effectively in our country? Thank you very much.
Exactly. Given the resources, in fact, it's one of the area. And when I came back from PhD, is one of the things that we wanted to do here. We want to like be able to be leased out some MTN BTS to be able to help us use only 2 BTS to be able to localize drones, to be able to localize a person that is having a handheld phone and moving. It can be done. We were able to like have data set of signals. In fact, we did energy harvesting using the data that we had, not for localization, but actually we wanted to extend it to localization, whether it is in the indoor, in the outdoor, in some shops, it can be done. Exactly.
Thank you so much. And the questions are already answered. And we want to appreciate all the presenters, both physical and online presenters, who are taking their time to come and present either physically or online, and particularly the online that have also stayed true. For those of you online that have challenges presenting, we have tried all our best to get you presented, but unfortunately, you still could not present because of some of the errors that also came from issue of devices, the kind of documents that are being presented. So we may not be able to take any other presentation at this time. We need to round up this wonderful conference that started on Monday. And I believe that all of us at one point or the other have gained one thing in our own area of specialization, either in mathematics, pure applied, either in statistics, either in machine learning or AI. We have been able to pick one thing or the other. For me, I've been able to pick a lot throughout this during these sessions. And so we are now going to be closing this meeting. And I must say that I appreciate everyone, all our professors who have been seated from beginning to this point. Please let's appreciate them. Yes, it's a good thing when you see people who have gone ahead and who are also trying as much as possible to invest in younger ones and in the coming generation so that we can get it right and even better than themselves. So on this note, I'm going to invite our director, who is going to be giving a closing remark on this conference. Please, let's appreciate our dear prof as he comes to give a closing remark. Thank you, sir.
All protocols to be observed. I want to appreciate every one of us for staying true. It's been a long week of deliberation and a lot of talks. And I want to believe that one way or the other, we are linked with different keynote speakers to different different participants that are giving one talk or the other. I want to also appreciate all our professors, both the one present currently and the one in absentia, all the keynote speakers, both the ones that came virtually or physically. And we appreciate every one of us and Professor Shegun Oyedeji. Thank you so much, sir, for staying true. We appreciate your presence so much. And Professor Abolari, thank you, sir, for giving elderly advice, supervision, correction. We thank you. We cannot take your presence for granted. You always show up. How far? Where have you? What have you been doing? Thank you, sir. We appreciate it. We thank all the technical group. Thank you so much. Anytime there's any obstruction, we are always there to do things in order. All the people in the kitchen, we appreciate all of you. We don't take it for granted. Hospitality, the protocol, security session, the editorial group, the planners, the program, MC. Thank you very much. And his group, we thank you. The media, all of you, we appreciate you. I want to appreciate my brother there from Rhodes, right? Rhodes University. He has been here since Monday and he stayed all through. Thank you very much, South Africa. Thank you very much. We appreciate you. And every one of us, I may not be able to mention everybody. I want to say thank you. The man from Jos, God bless you. Thank you for coming. Yes. So listening to all the different talks, the keynote speakers and all of that. Some of the people that presented online, we also thank you for saying true. And I want to say one or two things. Some of our observation from most of the talks, especially the one we have had online, and some few ones physically, we have observed that a lot of us rushed some of the slides. We see from the talks, some of us were given, and then we could not really differentiate from presentation and paper. So when you are presenting a conference, you should present a slide. You don't come and present your paper for us. It doesn't really speak well because you will not be able to. When you are given 10 minutes and you are just scrolling, you can't enjoy the paper. You can't enjoy what you have done. Now, if you are given 10 minutes, your slide should not be maybe between 10 and 12 slides. Because you know that 10 minutes, you have 100 slides. How do you want to cope with that? So all of this, against next time, if you know that, okay, 10 minutes talk or 15 minutes talk, the maximum should be 15 to 20 slides. So that within a few minutes, you finish what you want to say and people can, contribute or make comments or give suggestions. And then maybe going forward, we are also going to make a template. Like if you are coming to present, we give you a template and then you walk through that template. If you are not going to walk through the template, we are going to drop your talk so that we'll be able to accommodate those people that are following the template. Now, I don't know, somebody, you are coming to give a talk and then your work, you don't have an aim, no objective, we cannot really see, we don't understand what you are doing, no question that you really want to attack, the methodology and all of that. And then the result and discussion and then the conclusion. And some of the one we have also seen, we have seen people who have presented talks without any citation. We didn't see, it's just like maybe you just wrote a story and then no citation, So these are things you should be careful of. Now, you should, my mindset or everyone's mindset should be that anything you are doing locally, we should think of a global mind. You should have a global mindset. That one day you are going to present to the world. And then how do you want people to see you or view you? Now, even though you are here in Oye Ekiti, or you are in Ado, or you are in Akure, does not mean that you should make yourself local. Now, we should always have a global mind. Now, anything you are doing, you should have a global mind, because the conventional way of doing it, you can imagine now, if I come here, and then I want to I want to dress English. And then I wear shirts, and then shirts, and then copy. So I talk with my what's it called? Then I've got the top. And then this is Dubai, and then this is shirt. Is it the way it's worn out globally? You understand? Eh? So people will be laughing at you that are you sure this guy is taking straight? You know? So there are certain things you just know that it's not the way. Are you getting me now? So the same way with science, research, presentation. You want to present, your presentation should be presentable. So when you say presentation, it should be a presentation, not a paper. Not what's it called? You don't give us 45. Like I have seen so many people today. They just came up with like a finished paper, 45 pages. Present that. These things, like if there are other, the people from outside there, they will just be laughing at us. You know, they'll be laughing at us and say, does these people really know what they are doing? So we need to begin to think conventional. Don't conventional. And that's the reason for conference like this. So that you can learn how people are doing things. You learn, you relate with others, and then make somebody, when you present and someone is trying to make some input in your work, you don't argue. Like the other person, he was arguing, but he was arguing blindly. And you see, you don't learn by doing that, because we have come here to learn from each other, so that at the end of the day, you improve your work gets better, and then you are able to publish it. So I think that's the essence. So please, we want to encourage every one of us that going forward, we should always ask, I'm going to present, how is it being done? Even if you don't know, there is no crime asking. Maybe it may be your first time. Doesn't mean, there will always be a first time. Well, let's make sure that we ask, how is this thing being done? Even if the conference organizer did not provide a template, you should be able to ask, how is it being done? If you have not attended any conference before, ask questions so that you'll be led properly going forward. Now, on that note, I want to wish us a wonderful time as some of us will be traveling. I wish you a safe journey back to your location. And it's my prayer that the investment you have made concerning your research, your science, is not going to be a waste. This is going to be an addition to you. And we hope that in the future, we will see you in a great place. You will not remain small. So now, in 1 or 2 weeks time, what's today's date? Today is 5, right? Let's say in 11 days time, we'll be having another conference and workshop on mathematical biology. We have about 4, because after we have already put this together, I was feeling like, but eventually, because I've met those guys before, and they said they want to come. So I had to say, okay, no problem. We are using this one to send forth our outgoing VC. And then we use that one to welcome the new VC, because it's going to go from 16th of February to 21. So we have people, in fact, they sent me their visa last week, that their visa have been approved. 4 of them are coming from India. and they will land on Friday, I think Friday 13th. So they'll be here 16 to 21. And if you are interested, some people have started applying. You can also come, but that one is focused majorly on mathematical biology. So we want people in medicine, this thing to come around. It's going to be a wonderful time, and it's going to be at, we are planning to use 1,000 seater there. So, I believe that if you still want to come around, it's not a crime. You can come to learn. It's going to be workshop, and then 2 days workshop and 3 days conference. So you are invited. We are going to start sending the flyer out from 11th to every platform, especially Foyer platform. So it is nothing like that. So where do we? No, it's not been sent to Foyer platform because of the photo there. Put it out to Foyer platform. Because we don't want to receive knock on our head. So there are no two keys that can exist in the place. So there will be conflict in discipleship. So we have to unlike the thing. So okay, so make sure I mean maybe some of them have been sent out from outside Foyer. But for Foyer, we'll be sending it on 11th. From 11th forward, you can get it, and Foyer you can just apply, and then we'll take your application at least till 12:13. Stop. So thank you very much, and have a safe night.
Thank you so much. All right. So yeah, Prof has done justice to the announcement about the conference. Also, please, our social media platforms. We are on LinkedIn. I wouldn't know, can the media help us display some of our platform, social media platform? We are on LinkedIn. We are on Twitter. You can just search for Ikauda anyway. Okay, and then the flyer too. Do you have access to that flyer? You can actually display that flyer, the flyer for the next conference or workshop. Okay. So I said we're on LinkedIn, we're on Twitter, we're on Facebook, we're on Instagram, and we have YouTube, a very functional YouTube platform where you can see some of our past workshops that we have done before. Some of the courses that are taught there, you can access them online, and then you can also reach us through our website www.ikamda.org. I think if you check that website, you can see a lot of things that we do. You can always connect with us. www.ikamda.org. At this point, I want to say thank you for staying true. See you next time. God bless you.
Okay.
Okay.
You can go for your lunch now.
Hello, question, sir.
Demand
Hello, question. Hello, question, sir.